I hope the people online can hear me. So Laura, Shigi, and Sylvian. If you can hear me, just give me a thumbs up. Perfect. All right. So my name is Masi. Masi Wangi Wamboi. Only for today, you can call me Wambo. So again, thank you for coming to learn more about one of the greatest, or let me say, one of the technologies that are hands down changing the game in all industries, whether you're in healthcare, you're in business, you're a farmer, everyone is talking about agents. But we organized this masterclass because everyone is talking about agents, but the way they are talking about agents is in a manner where everything is an agent, when literally not everything is an agent and not every problem needs to be solved with an agent, right? So this is the whole gist of this entire day. It is to spread awareness, and not just awareness, but knowledge about what exactly an agent is. And hopefully by the end of today, you not only understand what an agent is, you also understand where you need to start if your goal is to build agents, if your goal is to utilize agents, if your goal is to, whatever your goal is in the domain of automation and agentic systems, you are absolutely in the right place. So the theme of today is what are AI agents, how they work, and where you should start. So today we are going to break down our early morning and our early afternoon into 3 sessions. The first session will go deeper into what is an agent. And I'm not going to give you the technical definition. I'm going to give you a checklist that says an agent does 1, 2, 3. So when I see a system that does 1, 2, 3, you know this is an agentic system. And by knowing the functions, right, the bare bone functions or the bare bone characteristics of what an agent is, it makes it even easier to identify use cases in your business, in your workflow, if you're in tech, if you're not in tech. I feel like when you understand the bare bone functions, the characteristics of an agent, away from the technical definition of what an agent is. Oh, if you're joining us online and you're currently here, make sure you, you mute yourself, and you also mute the sound from your speaker screen, right? So here, it will not be an agent is the mathematical model. We could absolutely go through that route, but it's more useful if I tell you the same way we define who is a woman. A woman has long hair, a woman has slender hips, That's exactly what we're going to do for the first session. In the second session, you're actually going to look into what are the building blocks of an agent. When we say an agent is able to make decisions, what is this about an agent? Its mechanics that enables it to make decisions. When we say an agent is able to interact with the outside world, what are these mechanics enabling it to interact with the outside world? This one will be a little bit more technical, but really useful to really understand what goes behind the scenes of an agent. How is it able to, when you put an agent in a workflow and it's able to give you output, what internal mechanism is running that enables it to give you an output, or it enables you to think, etc. And then lastly, we're going to close for the last 15 minutes is, if you want to build agents, where do you start? If you do not have any technical experience, you can build agents. Thank God for technology. And the not technology, but there's a movement currently called no code, where technology has been democratized, if I'm saying that word correctly. Like, no longer are the days you had to have a computer science degree, da 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 da. It's all about, can you do, can you ship. So depending on where you want to be and where you are currently right now, if you want to go the no code route, there's a place you can start. If you want to build custom agents from scratch, you're the one defining and building that agent brick by boring brick. There's also a specific place that you can start. All right, let's get going. Somebody should keep me accountable time-wise. Just set my timer here. Perfect. Great. Go ahead.
I hope we'll get the recording even
Yes, you will always send a recording and a copy of the slides. Okay, so what is an AI agent? I kind of want to see the feel of the room and see if anyone knows what agent is. I'm just going to pick the one right next to me, Paul. I was going to, and there's a question, what do you think an agent is? Don't give me the technical blah, 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 just from your experience, what do you think an agent is?
AI agent from artificial intelligence. So I can say it's more of a branch of artificial intelligence.
Okay. Anyone who wants to add on top of that, what do you think an agent is?
I would say it's like a virtual assistant.
A virtual assistant is an application of an agent. Right? What's running the virtual assistant? That's what I want to talk about that.
Oh, okay. So what do I say? It's a custom made, more like going to replicate a human. The human that you can be able to give instructions and you can be able to execute those instructions in whatever environment that you have.
I like that. Replaces a human, executes instructions. Good. We're off to a good start. Let me be general about this. What do you think an agent is? From your own words, no right from us.
I think an agent is the best of
What I'm getting from you guys is an agent that is something that does a thing. It executes a thing without the need of a human. Let's take that definition even further. So an AI agent is a system. And it's a system because it needs a couple of things, right, to be able to execute this thing that you've told it to execute. So it is a system that, one, pursues a goal. And this, I'm underlining pursues a goal because this is what differentiates what an AI agent is from an automated system, right? So there's a big difference between automated and autonomous. And when you go on LinkedIn and you go on Twitter and you go on social media, a lot of people are, what they're calling an agent is actually an automated one. And by the end of this thing, you're going to understand why when I see those LinkedIn posts, I clench my fists, right? So an AI agent pursues a goal. It's not told what to do. It is told, this is the outcome I want from you. Very different from an automated workflow. Have that in your mind. An AI agent also acts iteratively. right? It takes actions over and over again using what we call tools. And I'm going to tell you what a tool is in a couple of minutes in the context of agentic systems. So it takes steps over and over again in pursuit of a goal. And it evaluates its progress. So it will do task number 1, look at the result. Am I closer to my goal? Yes or no? Do that process again and again without it being told what to do. It acts implicitly. Automated systems act explicitly. Instructions of automated systems come from outside. Agentic systems make the decisions themselves. So when my kind sir here said it replaces the human, you're absolutely correct. Agentic systems are supposed to replace your decision making. Automated systems just help you cut loose of repetitive tasks, but you have told it, I want you to start on Monday, then Tuesday, then. But an agentic system will optimize. Should I start on Wednesday or Thursday, given its environment? So let's break down these bare bone components of what an agentic system is. So one, an agentic system, we've said it pursues a goal, right? ChatGPT is not an agent. Let me break it down. All right? I know most of you, I'm assuming you came here knowing I have interacted with an agent called ChatGPT. ChatGPT is not an agent. Why is ChatGPT not an agent? Because ChatGPT, you tell it what you want, right? You give it instructions. You tell it, I want you to write an email to my boss, da 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 da. So ChatGPT is a tool you're using, right? So an agent pursues a goal. It doesn't respond to a prompt like we do in ChatGPT, right? You give it a goal. You say, let's say an example of a goal. Let me see. Give me an example of a goal that we can give. An example of a goal we can give. We could even say customer support, right? Your goal is to receive emails from customers and give them the best way forward, right? If ChatGPT doesn't have context on the outcome you're looking for. It will just give you, you said you want an email, I will give you an email. It doesn't know this email, it was written by your boss in response to another email in response to whatever. So an agent, you only give it a goal. You don't give it necessarily instructions. Now, an agent also runs iteratively, right? It doesn't run once and stop. It goes through a continuous cycle of it acts, it observes, it decides, it acts again. And it's always towards the goal, right? It has the ability to think and make decisions for itself. We will not go into the mathematics of how agents are able to think. That's a whole science there. But it runs over and over again. An automated system runs until it stops. It runs when it has a defined start and it has a defined stop. So if I say you walk from here to town, right? It will walk from here to town. But an agent, if you tell it I want to lose 5 kgs per week, it will design a plan for you and not necessarily you walking from here to town. All right? Now, an agent repeats the steps until the goal is achieved or until it determines itself that it's maybe missing a critical tool or a critical data or information that prevents it from going forward. An agent also uses something called a tool, right? Now, tools just let me go back to ChatGPT. If we were to give ChatGPT arms and legs and ears, right, we would be able to give it access to your email. Because ChatGPT, the way it is right now, it's just helping you think, but it's not helping you take actions. So it can write for you the email, but it can't send for you the email. It can write for you the email, but it can't schedule when that email is going to go out every day or every evening or every Monday morning. So tools are what give agents their arms, legs, ears, enabling them to interact with the outside environment. Otherwise, ChatGPT will always stay static. It will just be conversational. But when you give ChatGPT tools, its ability to send an email, book a flight, call a client. So agentic systems, all that ecosystem also has what we call tools. So you can think of tools as a way of us coming out of the chat bubble and being able to interact with the outside environment. And lastly, an agent isn't told what to do. An agent is given a goal and figures it out because it has intelligence. Right? So an agent figures out what to do next, given the tools it has. So an agent, if you tell it, I want you to book for me a flight. So you'll give it tools like access to Kenya Airways, you'll give it tools like access to the weather, or you tell it, I want you to book a vacation for me and my family. So what are the tools you give it? Access to the internet, maybe, I don't know, booking.com access so that you can find a villa for you, right? You'll give it access to KQ, right? So that it will, because it already has access to the internet, it will just look at the internet what flight is best, when is the best time to travel. You give it a goal, you say, I want you to organize this vacation for my family, and it will figure out the steps. It will say, what time of year do you want to go? What kind of holiday are you looking? Are you looking for beachy or for the mountains? And you don't explicitly tell it that, look for me a beach. It just figures that out, of course, but with guardrails, right? So agentic systems are those four things. If you never understand the technical definition of an agentic system, just understand it does, at its core, it does these four functions. It pursues a goal, it runs over and over again, it uses tools, and it decides its own steps implicitly, given the goal you've assigned it and the tools you've given it access to. All right, now the question is, from what we've just covered, are large language models like ChatGPT, Gemini, Claude, etc., are those agents? What are they? Yeah, tools. Exactly. You tell it to do something and it gives you an output, right? So we have this thing called autonomy. And I started this session telling you that a lot of people are confusing automated and autonomous. An autonomous human being is a human being that has self-determination, right? Self-direction, and that's what agents are. So agents, or rather, it's a more technical term, we call it the autonomy spectrum, right? And agents exist in this autonomy spectrum. At the very tail end, we have a tool. A tool is just, it is capable of doing one thing. Okay, ChatGPT is a tool and it's capable of doing many things, but the way you interact with ChatGPT, it is conversational. I ask for this, it gives you this. You ask for this, it gives you this. So in that scenario, you're using ChatGPT as a tool. ChatGPT is a tool. It is not an agent, right? Now you can build other things on top of ChatGPT to give it agentic capabilities, but the ChatGPT we all know and use to write emails, to code, all those things. You're using ChatGPT as a tool, right? And it's because a tool has no awareness of the goal. It has no sequence. It doesn't follow steps. When you tell it to write an email, it's not like it's just going to give you an email, right? It's not following, there are no predefined steps before it finally writes for you an email. So it has no awareness of the big goal. Why are you writing this email? Who is it to? What is the background of this conversation? What is the context of this email? A tool doesn't have that. It has no sequence and it has no memory. All right? It does nothing unless called by the human. Right? It is used by the human. So a good example is asking ChatGPT a question. On the next layer in the autonomy spectrum, we have an automated workflow, which we in the text space just either shorten it as automation or workflow. But the more academic term is an automated workflow. And what's an automated workflow? An automated workflow is a chain of events. Or no. It's a chain of tools and events. Right? It's a chain of tools and events, and it's triggered by it has a start event that triggers the automation or the sequence of tools, and it has an end event that you come out of the workflow, right? The difference between an automation and an agent is that each and every step in your automation is defined by you, the user, right? How do you want to get to Nairobi? You go down the stairs of Parklands Plaza, stand there by the corner, get a matatu to MK, go to Ghana, so on and so forth. And by the end of this session, I'll show you an automated workflow that I personally use as somebody who's constantly hiring, right? So an agent is at the highest layer or section of the autonomy spectrum. It's because it's given a set of goals, it's given tools it can choose from. So you don't even define the tools, you just give it a box of tools and it figures it out, right? Does it need a wrench? Does it need a hammer? Provided you've provided the hammer and the wrench, it self-determines and optimizes which tool gets me to my goal the fastest, and decides everything on its own. So a good example is, and the steps that it takes is not defined by you, but it's defined, I don't want to say on the fly, but that's the easier, that's the more English term. So the steps that it takes is determined on the fly. What we call, it's very dynamic. So the way it will handle customer A might not be the way it handles customer B, because it has context on customer A and customer B. You can even train an agent to handle the premium clients way better than client tier 4 or whatever, right? So this is, an LLM is not an agent, an LLM is a tool. So now we know the difference between agents and automations. So automations are sequential steps defined by you. An agent, you give it tools, you give it a goal, and it figures it out how it's going to do it. Now, there are specific use cases where it makes sense to have an agent, and there are specific use cases it makes sense to do a simple automation. But we're going to go through two scenarios of where agents, they are popular for this. They are taking the tech space, the insurance space. I don't know how many of you are so impressed by KRA. Have you filed your taxes with Shuru? Amazing. How is it? I mean, though I don't trust the government, I mean, it made filing returns easier. Because I had to pay 1,000 more for somebody to do my returns. Because all the consultant, you have to do it. Yeah. Right? But Shuru made that entire process. I even asked it questions about e-teams. I was like, at least, okay, are they there? Good job. So why do agents adapt where automations break? And the best way to just go through this is through a simple example. We'll go through a scenario. So my scenario here, I don't know if there's a question online. Yes, Shuru is amazing. Let's give the government props. There they did a thing. All right. So scenario A is you can build an automation that replies to customer emails. And this is something that many businesses are doing. And it works, by the way. I've seen it doing, we've built it for a couple of our clients in town. We just built a simple chatbot that clients are able to ask, right? How much is this? How much do you charge for this service? Blah, blah, blah. You can absolutely expose a database of your frequently asked questions there, right? And an automated step, an automation is able to just pull that information from the database and give the appropriate response to the client. Now, I'll give you an example here. We created a workflow for a client to handle customer support emails because she was having a hard time doing TikTok lives, because when she goes on live, no one is manning the questions coming in on WhatsApp, and she didn't want to have to hire somebody else, and their only job is to handle WhatsApp messages. And there are specific times in the day that going live on TikTok creates more traffic and gets more money than, so she couldn't be at two places at the time, and she didn't want to spend the 15,000 to hire somebody else to do just one task. So we created a workflow for her where this workflow comes in. People are sending in inquiries through email, and the email has a subject line. So we created a workflow that reads the subject line, right? It reads the subject line, and then it's able to redirect to whoever it needs to be directed to. So if it is a billing question, it goes to, she knows this is in finance and she has a way of handling that. If it is a technical issue, she goes to the IT card. She was doing all of it. She was a startup of one. And then general questions would go to the general bucket, and she had a way she had prioritized which bucket she starts with. Of course, you start with the money. She start with finance, she start with IT. And she also wanted to track where most customer complaints, in which bucket most customer complaints were happening. So one day, she got an email landed. It didn't route the way we expected it to route, and she got a very angry customer email back. You guys you're not listening, I've paid my blah, blah, blah. So when we investigated, it happened that this email, the subject line said this: "Hi, I've been charged twice and I can't log in to fix it." Now the workflow instructions, and this is now an automated workflow. We gave it instructions. Read the subject line. If the subject line says billing, put it in the finance bucket. If the subject line says technical, put it in the IT bucket. Anything else, put it in the general bucket. But how do we handle that? We call them edge cases. Right? It's a case you didn't anticipate for, and therefore you didn't put guardrails to address. So this is simultaneously a finance issue and an IT issue. So the workflow broke because it doesn't know, do I take it to finance or do I take it to IT? So you have two options. The workflow can either break like ours did, or sometimes it randomly chooses and therefore it reroutes it to general, right? And it gets lost and the client is not happy. Now, that's an automated workflow, and those are the limitations of automated workflows. If anything deviates just a bit, the workflow breaks, or it produces the wrong outcome. So this is a perfect case for where an agent would have done this with more finesse. So we replaced it with an agent. We are feeding it and exposing this agent to the same database of frequently asked questions. Now, in these examples, we're not only giving it frequently asked questions, but we're also exposing it to how she responded, right? So they are the questions many people ask, and we're giving it a history of how they were addressed in the past, right? So this agent sees the email. It doesn't just read the subject line, but it reads the entire context of the email because it's able to think. And then, because it's able to think, it gets better context. And it recognizes that now this is a multi-bucket issue. This is not only finance, but it's finance and IT. Now, for this particular client, like I said, we also exposed the agent to client history. For clients who are returning customer grade A clients, you want to sort that issue very quickly. Even in the banks, the guys who are removing victims or bank right? They go straight to the manager. Straight. Right? From the door, and remember, yes, Kubwa, media office, right? And we implemented something the same for her because we had history on, she used to have like promotional points. So we could categorize clients based on the points, and we could prioritize the clients who are returning clients, spenders, blah, blah, blah. So using the agent, an agent is able to have context. So if you give the agent the right tools here is access to a database. The right tools here is something to enable the agent to understand text, to understand PDF, to understand Excel, and that sort of thing. So an agent was able to handle this with finesse. So that's the difference between automations and agentic workflows, right? You can have an automated workflow and you can have an agentic workflow. An automated workflow works perfectly for repetitive tasks where there isn't a lot of deviation, right? So if you're always sending a report you're sending the same report every day on Monday, automated task. There isn't a lot of deviations, reports needed. But if you are anticipating there are going to be some edge cases and you need some dynamism in how those cases are handled, or the outcome changes case by case, that's a prime candidate for agentic workflow. So how do you tell if a task needs an agent? Now, there are so many ways of doing this, but I've kind of summarized it into these 4 pillars. Number 1, does the task vary? Right? Is there any dynamism or variation in, is the output, does it need to look different every time? If there's that kind of variation, prime candidate for an agent, because an agent is able to contextualize. So it's going to handle scenarios case by case. And how is it you want, because when you're handling scenarios case by case, you are thinking, and an agent has the capability to think. But our workflow follows a sequence or tools that are triggered to start or stop using an event. Number 2, does it require you checking something before you make a decision? Basically, is it rules-based? Like, how hard-coded are the rules, right? If 1 + 1 is always 2, automate that process. But if 1 + 1 for any given reason is 11, that's a prime candidate for agents, because again, agents are able to contextualize. If you need any dynamism or contextualization of any form, and your rules are not hard-coded, right? So A + A is not always B, it's B squared. That's a prime use case for agents. Another thing is, does it have a goal and not just a trigger? A trigger would be you need to send reminders to your team every morning at 9 a.m. That's just a trigger. But is there a goal, right? You need, and maybe the goal would be you need to send like work plans, right? Let's say, and each you're a manager and you're sending like personalized work plans to your team. So you require something that's able to know or has access to what was my team working on before and what do they need to prioritize today? What are the company's OKRs? In what sprint are we in? Right? It needs that kind of um, dynamism. It's not just a trigger, but it's a goal. And the fourth thing is, would a fixed rule handle it poorly sometimes? Does it fail sometimes? If you can ask, a trick actually is to ask yourself if then questions. If this happens, then what? If you find yourself every time you ask yourself if then questions, you're answering the same thing, just automate that process. You do not need an agent. But if you find yourself sometimes when you say if this happens and your then keeps changing, it means you need a little bit of reasoning behind your system. And therefore it's a prime use case for building an agent. Now, I'd like us to do a very, very, very brief task together. We are in our final 10 minutes. I think it's been an hour already. I want us to do a simple exercise to identify your day-to-day work. Whether your day-to-day work is studying, you're still in school, whether your day-to-day work, you're in business, you're in whatever domain or industry you're in, I want us to quickly identify tasks in our workflows that we can either automate or need agentic systems, right? I'm going to give you about 5 minutes. If you have a notebook, go ahead and write it in your notebook. You can write it in the notebook on your phone. Yeah, and then I'm just going to randomly pick out people to tell us about their day. Okay? I hope those online are also with us. So let's do this task together. How does your day typically look like? Break your day into the tasks. So if you wake up and you check emails like the rest of us, the first task is to check your emails. If the next is to write a to-do list, your next task is to write a to-do list. Right? And then what are the components of that to-do list? And then let's see if we can be able to pinpoint somewhere in your own workflow that you're able to automate hopefully in the coming weeks or build an agent without a lot. All right, who wants to be my guinea pig? All right, we'll have the missus in the beautiful yellow sweater. Take us through your day. Tell us what you do, take us through your day, and then let's see if there's something we can automate or there's something that needs an agent.
Thank you. People start to say not all these are similar, but generally, just check my email, prioritize what needs to respond, maybe there's some information I need to fill in before I can respond. Of course, there's some emails that are also for meetings, so now start professionally a meeting for that. Of course, now, at the nature of my job, normally work plans for weekly activity. So, yeah, it's any reports that is needed from the activities that are scheduled for the week. Do the reports, then the relevant people. Is if I need to do something physically to prepare for those activities, I also do the same. And then updates meetings for the office, make phone calls to partners. I work in an work, so there's a lot of engagement with partners, but now it's on different ways. It's not something particular. You find in some regions, for instance, if they are implementing the program is the same, but now the youth are implementing the programs for children, for adults, for youth, and also different regions. Now they started also different times. They need to start specifically such that if the assessment, consider the assessment to be scheduled. So it's something that's varying. Of course, now attend meetings, if there's any arising matter that needs my attention, I'll also take that.
What's the most repetitive part of your day? And start there.
Phone calls.
Phone calls. Meetings. And meetings. Okay. These reports you're sending, how do they look like? Are they more or less the same? So you said you send reports for certain activities, right? Are they summary reports or are the reports structured in a way?
They are.
What are the activities?
For instance, maybe trainings.
So you're reporting that the training happened at this time,
Yeah,
and these were the outcomes and all that.
These regions. Yes. Maybe the assessments in some areas their training is happening, in other areas the assessments, in other areas that those who are completing, so they're graduating, we call it graduation.
What if in those meetings, you're recording those meetings, right?
We use WebEx, but now there's some that we just attend without.
So what if in those meetings, to help remove the whole report, right?
Yes.
Because you're reporting on activities,
Yes.
right? You're not thinking, it's, they did, right? So I'm assuming when these activities happen, you have a debrief, right? So you're the lead, there's somebody who's actually executing, and you have a meeting and it says, we did ABC, this was the number of participants, or do they have some notes? Why not record that meeting? Pass it through an agent that's able to transcribe the meeting, and the output of the agent is a report that you told you. Everything we have discussed in this debrief, can you summarize what we've done and send to the executive? So that activity, you can, I hate reports, right? I don't like reports. If the report doesn't have numbers, I have no business writing it. So that could be a candidate place in your workday that you remove that, right? And it's an agent that can be used across the entire, anyone who is in a meeting and in a debrief, because I know we do debriefs, Yeah, just summarize what everyone has said, and you can give it the exact structure of the report you want, and it will provide that report for you. And your role is only to proofread and to like change here and there, but very doable. What do you do? How does your day look like?
Let's say, what do you do mostly? Maybe jobs last week. Starting through reading, maybe that's
I'll do you one better. The job market is tough. People tough. People tough. If you are looking for get opportunities faster, doing job search on websites is not the most. You need to come hidden job market. So for you, I actually have a similar workflow, but mine is for now behind the scenes as I'm the one who's hiring. So I have a CV screener and I'll demo it here today. So for you, I would build so if you go the no code route, you will have it running in 2 weeks. Build a lead generator for LinkedIn. There are companies you want to work in, right? Let that agent go on LinkedIn and search for people in this company, right? And then it's like you fed it the people on LinkedIn and you fed it the company profile. So like feed it the website, right? Tell it to look for news about the company and stuff like that, right? And then tell it to write for you connection request. You know, in LinkedIn, you can write a connection request and like write a message, write a connection request. So it has context on what's popping in the industry. It has where it is. Like if I was a hiring manager in Safaricom and you come and tell me, I'm really like you guys launched this I'm a machine learning engineer, and I feel like this is where you know yeah, of the I'm thinking about this product for you guys. Let the agent do that networking for you. That's how you get into the hidden job market. I feel like you'll get better. And you can absolutely build that on any time. And now I'm challenged. I like the idea. So any last ones? And I can go for it. Okay. It's more or less something I do forget years, comment. I mean, it's easy to have replies and comments. I would like to have a way where the is to have like sentiment analysis, which to see what people are interested in, which can guide decision. So it's really good to see if I have an agent in this one. I mean, there are restrictions with the wait. You just start from the top so I can understand it. So I'll get like DMs, comments for a long period of time, and maybe I want to analyze what people are talking about or what people are interested in. Sentiment analysis, I think it's called. Yes. But it's kind of difficult because you have to like go through everything and to have like a so somewhat of an outlook. On what platform are you Instagram? I might get influx of things, but then I just go off my head like I'm but I would like to have like quick. So the first thing you need to do, because you're on multiple platforms, you'll need to consolidate all that data into like one area, right? And it's very easy. You don't even need a complicated agent. You honestly need like ChatGPT to come and tell you, because what is your task? Your ask is, I want somebody to summarize what people are asking me about. Yeah. So yours is more, you don't want the ChatGPT to necessarily think, you're using it like a tool. Yeah. You don't want it to make any decisions for you. So you can definitely have an N10 workflow that consolidates. So like send everything to a Google Sheet. Yeah. And you can have like, you can have API calls. So that API call to to Facebook, to Instagram, to TikTok, and then what the output of those three, you merge them into a Google Sheet, then your agent reads your Google Sheet and knows, and you can write a code that I want you to read from the last 7 days, because you can have dates of where those DMs came in. I want you to read from the last 7 days, and every Monday morning, before you do your whole content plan for the week, send me an email summarizing in 5 bullet points what people have been asking me about. Right? So I will share my day to day. So one component of my role is I have a lot of people sending their CVs asking. So I have a lot of people sending their CVs to me asking for, is there an open role, da 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 da. But I can get as much as 20 CVs in a week. Given everything else, I do not have time to go through 20 CVs in a week. So I created a very simple automated workflow, right? That whenever somebody sends their CV, we have a form and you fill in a couple of details and you attach your CV. So I wanted somebody to be the one to read the CV and determine if they are a good fit. And then I score their CV against the job description. If I find an 8 out of 10, that's the CV I'm opening. If I do not find an 8 out of 10, if I do not find an 8 out of 10, I'm not opening that CV. So I have created my own personal CV screener to save me some time to go through 20 CVs, right? And I'll demo it here. So I don't know if I need. I don't know if they can see it. So this platform here is called N8N. And I said the beauty of the times we live in is technology has really been there. You don't know how to code, no problem. We got you. We have a way for you to use agents and build automated agentic systems using no code. So this is what we call no code automation, right? And you can see I'm able to achieve so much using only 4 steps, right? So this is my system. My system here I have, this is N8N. So N8N is just a platform, it's a no-code AI automation platform. If you do not know how to code in Python, or you just want to get going really quickly, and you don't want to learn the internal mechanics of an agent, or your use case is so simple, it doesn't require you to customize an agent from scratch. N8N is where you get that value. And confessions, I'm a data scientist, but I do not know how to build an agent from scratch. That's a whole science. So my go-to is, I know the mechanics of an agent. My go-to is N8N. It gets me started really quickly. And I have a couple of workflows, but this is by far what has saved me. I think it's what I've used in a couple of weeks. So I'll take you through simply what my workflow is doing here. This is a workflow. A workflow. Oh, you're the one share. So I share? Yeah. I hope now everyone is sharing. So in a nutshell, what my workflow does, anytime somebody submits their CV, the workflow is triggered. Trigger just means the process, the sequence of events starts. So when you send in your CV, I extract information from that CV. So if you're sending it as a PDF, if you're sending it as a Word document. The way an LLM consumes content is not the way you and me consume content, right? It needs to be translated in a format that ChatGPT understands, right? Next, I have what we call a basic LLM chain. This is not an agent. This is just me calling ChatGPT and telling ChatGPT, I have given you this JD. Look at this JD and look at this CV. Tell me the strengths, tell me the technical gaps, score this person, and then once you're done, send me an email. So every morning, or not every morning, every time somebody submits a application for any role that I am hiring for, I will always get an email with the score. If it is an 8, I look at it. If it is a 6, I put it somewhere and say, not due, right? So let me take you briefly through in-A10, just as a teaser. So in in-A10, we have things called nodes. Nodes, you can think of them as a capsule for an action. So node 1 is a form submission node. Node 2 is the one that extracts the content from the CV that has been submitted. Node 3 is what has the ChatGPT brain. And then node 4 is what sends me the email. So let's do a very quick test of the workflow. Then you can see what I receive. All right. So here I am testing the workflow. I can go for it.
Okay, like now in the workflow.
Yes.
Let's say for the someone who was not successful in the pandemic, LLM was evaluating them. Does it give them a feedback?
Now I can absolutely, you see now this is to send an email, right? I can put another note that if the person, I can put another note that splits the information here. So the information that's coming from here, right? I can put a note that splits it. So the one who gets a score of 6 gets a certain email, and the one who gets a score of 8 gets a certain email. It's all how you decide to design your workflow. And workflow design actually starts from, can you break down your process into logical steps?
What if someone has been many times applying? So like they applied this year, they get this shortcut, they have maybe in one way or another, they have scaled. And then now they apply next year that now it is also around 8, was scored. We need to be able to pull that applicant, show you that this applicant applied at this time, and not has applied at this time. I can see the scaling that he has done, and then now it can be able now to decide for you, tell you that this person is consistent, so probably they have.
That's a fantastic question. So remember, automated workflows don't have memory. So what you want is an agent who has that historical memory to say, what's your name? To say, Peter applied in 2024, and Peter has been grinding and has applied again in 2026. And he came from here, and now here he is where he is. Workflows don't have memory. Workflows are triggered, they do a series of actions, a series of functions, and then they end when the series ends. So this workflow doesn't have, if you want something like that, that's an agentic system that has that memory, which gives it context. Peter applied here, da 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 da. So here is the simple workflow. I'll just input my name, my email address. I'll just do 1, 2, 3, 4, 5, 6, 7, 8, 9. And I'll choose a CV to upload. And then when I hit submit, What is the problem? Yes. So you see, when the form is submitted, it now starts the workflow. If no form is submitted, I do not get an email. So I will always get an email when somebody makes an application. So nothing misses my desk, right? So let's see the kind of email I get. I don't know if you can see or those online can see. I need to share my entire screen. And there you go. You see? New candidate application summary. It's able to pull the candidate's name from the CV they submitted. It's able to pull the score. It's able to tell me their recommendations. So I've categorized them into several buckets. A maybe for Peter, who somebody just, something little is missing, right? A strong recommendation, strong no, a maybe yes, a maybe no, right? And then it tells me the strengths. What's their direct lived? So it will tell me the strengths as the LLM has decided. So for Mercy, direct live experience, strong proficiency in Python, machine learning algorithms, and then it will tell me my gaps, bachelor's degree alignment, right? I'm an agriculturalist, right? So if I'm applying for a tech event, for a tech role, some people might have questions, right? And then it gives me a summary. Wow, it's exceptionally strong. See, right? So that's how I filter out this many CVs that come through my desk without overwhelming me. Because if 20 come in a week, that's a lot. And you have to give everyone a fair chance. I don't skim, I will read. So this was taking up almost an entire day and just giving me backlog for nothing. So that's a pretty prime example of how you can take a task that you do in your day-to-day and you feel it has those characteristics of can either be automated or needs an agent. In this case, I did not need an agent. I just needed ChatGPT to help me compare and contrast the CV against the GP, right? You can see how that useful that is. And that's pretty much a simple example with only 4 nodes and no heavy technical. I guarantee you do not need to code to do what I just did, right? With just 4 nodes, all you need to know is where to get the nodes, and anytime is beautifully built. It has connections to a plethora of, you can connect it to Gmail, to Google Sheets, to PDF, to, yeah.
And it connect to apps.
Yes, provided the app has exposed, it has like a connector on Anytime, or you can find the API for that app. So if you want Twitter, you could. If you want WhatsApp, you
I'm
could.
seeing like custom apps, like, you see like the way you're using Zoho. So I believe you're also using Zoho in your accounting, right?
Yeah, can it connect to CRM like Zoho? I think so.
CRM,
It can. Yeah.
And accounting applications and that.
Provided it has a connector on Anytime, it can. Yeah. So you can check Zoho. You can see it has a connector for Zoho. So all you need to do is learn how to configure. And when I say configure, it's such a big word, but I trust me, the process is, if you can train a 10-year-old, they can absolutely do it. Configure is just the technical term, right? So if provided it has a connector on Anytime, right? You can, and the only thing you need to learn is how to configure the connector. And the process of configuring a connector has been made so easy by drag and drop. by virtue of the LinkedIn platform. All right, I think that's all from my session. Um, Franklin, I'm using an API key. So I'm using an API key to open AI, which is ChatGPT. All right, I think that's all from me. Do we have any questions before we have a fun break? And then now we dive deeper into, we do a deep dive into what makes an LLM. Go ahead, Franklin. Cool. Of Franklin question. Okay. Franklin, did you? Yes, we will share the meeting recording as well as the slides after. Okay, all right.
Okay, I have another question.
Go for
Like
it.
the way you said that if you have an API,
Mm.
you can be able to connect,
Yes,
you can be able to connect an agent or information
connect to like applications.
on
Yes.
application.
So connecting to an agent, there's a specific node for that.
Okay.
Yeah.
So let's take your case like in data science.
Mhm.
You're retrieving data from databases.
Mhm.
And then there is a way you're going to form up that data and then now present that data on whatever presentation that you're using. So can an agentic AI be able to do that for you seamlessly without your interference? So once you give it instructions, please look at this data, what is the
Yes, absolutely. You can. So there, the skill is going to be prompt engineering. You need to give. So prompt engineering, you can think of it as how you give it instructions, right? How you give the agent instructions. So there, your prompt engineering game should be solid, so that it does the analysis as exactly as you want it.
It's part of the series.
Absolutely. Franklin, if there, we can't hear you.
Yes.
Franklin is asking, so instead of like an API key to a model, like, can he also use his local model in his computer?
Yes. Local models are the only applications that give you exclusive access. So,
Are you on the phone?
let me answer it in the second session.
Okay, Franklin, we have our AI engineer here. Yes, yes. So that your question will be answered in the second session. We have a brilliant AI engineer here, and he'll take you through how to do that exactly. Right? I hope that's okay, Franklin. Just give us a thumbs up. If there are no questions, I'll hand it back to Chris. Yeah, thank you, everyone. Awesome. Okay, so there's another question here on where I have put the job description. So in my LLM note, right, I have put a prompt. That's what I'm talking about, prompt engineering. So the prompt is instructions you're giving the LLM. The LLM here I've used, just think of it as ChatGPT. ChatGPT, Gemini, Claude, Kini, all of these are large language models. So a prompt is the instructions you give an LLM. So my instructions include you're an HR expert, you can see there, and a data science hiring specialist. Right? Your task is to evaluate a candidate's CV against the following job description, and here is where I fit the job description. I fit the job description and I give it how I want the output to be. Now, in as part of the masterclass series, we'll tell you how to build a good prompt. There are 5 components of a good prompt, right? And we'll go through that. You have to give it a role, you have to give it context, you have to give it restrictions, and that's a whole science, right? Prompt engineering is a whole, and I use the word science very loosely. It's a whole, there's a methodology to it, right? So to answer your question, the job description, I put it as part of the prompt, right? And we'll take you through how to prompt LLMs properly as well as part of the masterclass series. Any other questions before I hand it over to Grace? Yes, go for it.
Is a task that you really feel is quite ambiguous and doesn't deserve to take the time to take it.
Mm.
For instance, now for the people that undergo the program, we normally stick the names in hand. But not for us to print their certificate. We have to type all of names.
Mm.
There are ways that can be eliminated because it takes too much time.
To do that. Oh, that's an interesting challenge. Oh, now if you were to digitize that, like you could build a model. It's called the OCR model, so optical character recognition. So, for example, you take a phone, see, and you take a picture of the names that are written, right? And then that model is able to digitize. So it's optical character recognition. So it's able to convert the names on this image into, yes, and output something. So that's a little bit of machine learning, but it's absolutely doable. I think the government is. There's a person who created, you see how it's very tedious for agent number or even paid bill. Why am I inputting all these things? So there's an app, I don't know how far it went. Somebody created that thing. Let me even tell you another one. You see these people for Nairobi Water, they come and kusoma meter. Have you noticed they take pictures nowadays? Yes. So they take a picture of the meter, and then the system is able to recognize the characters or the reading of the meter, and then it just calculates your your water bill in the background, and then you get an SMS. So maybe that's what you would need, because the issue is the bridge between the physical and it's this translation that, so that one is not really an agent, that's a machine learning like problem, but very low. It's been done before.
How much time would it take to learn the prompt engineering? Big cloud.
I'll let that be answered in the second section. But to get good, like to get started to improve your outputs from ChatGPT, it's a rule of 5. You just need to do 5 things when you're prompting. So, but prompt engineering, there is the science, and I'll let the second speaker like handle that. Okay, Grace, you have the floor. Thank you, everyone.
hear me? Just give me a thumbs up if you can. Okay, that's fine. We should start in a minute. How's everyone around? The ones who are here with us in person? How was the first session generally? Scale of 1 to 5? 5? Yeah, that's nice to hear. I think we're missing a lot of people. We'll just, you've called all of them. So that's fine. I'm just going to share my screen. I don't know why it's not showing here. Then we'll go ahead. For those of you on the call, I'm guessing you can see my screen already. What I'm just trying to do is project it here as well. This doesn't connect?
Ina connect kwa umeselect which ukifinya
It usually comes here.
sure because kwangu inakuja kama smart
Kuna
TV.
mtu
Nisha disconnect us.
it comes like
Smart TV.
okay, sawa sawa. It's 15 on the dot. I just have a small request for the guys who are further. Just come closer. We'll have to switch to a smaller TV kind, and then you can go ahead. Just come to these seats, and then it should be good.
That should be
It comes.
yeah, that's that.
Okay, guys online, we're just fixing our display here. Just allow me. We have a small problem, and then we'll continue. Okay, I think now I'm back. Awesome. For the guys online, just confirm that you can hear me regardless. Once again, just one last time, and then we get started. We're running short of time. Okay, so now everyone can see my exact screen. That's fine. All good. Thank you. Thank you very much, Franklin. I think we'll get started. I hope you guys can also see my slides now, and then we can push that. If you're online, kindly, if you have a question, just unmute yourself and speak, because I'm just looking at the slides. That should be a good anchor. Okay, awesome. So thank you very much, guys. I know you guys have enjoyed the first session, right? The main objective of the first session was, can we understand? Oh. Okay, I'm guessing on the call my screen can be seen now, right? Awesome. And everyone, we are on tune on the slideshow. Okay. So in the first session, the core objective that Mercy was able to articulate really well is to understand, one, what's an agent. Second layer was to understand the opportunities, or when you switch from just a simple workflow to a particular agent, right? And that was the core thing. And I'm hoping you guys were able to get the gist of it, including seeing that CV screening agent. That was a good sample, right? There's fundamental things that I want us to just get straight here. When you talk about agents, it does not always have to be built by code, right? We can build agents with code, but you can also build agents with no code. In the previous session, we saw instances of how agents can be built without code. Now, in this section, or this phase of the session, we're going to do just one fundamental thing. We're going to ask ourselves what goes into building these agentic workflows. You already know what an agent is. Now we are asking ourselves, what are the components of building agentic workflows? And we don't care whether you're using code or whether you are using code. Each and every single context you're going to share here should help you, regardless of what approach you're going to go for. Just in general senses, my name is Cyril. I'm one of the co-founders here at Zindua School. I'm also an AI ML engineer, and we'll be using some examples that we've built to be able to answer the questions. Now, in the first session, there was a lot of questions thrown back at me, which I'll avoid till the end of the session, and hopefully the answers get solved as we go through the slides. So let's talk about what goes under the hood of an agent, right? Whenever we talk of an agent, the first thing we talk about is the brain, right? Who's doing the thinking? An agent is mostly anchored like as a human being. So where's the brain, right? And typically the brain is the model, right? We're used to saying I'm using ChatGPT, I'm using Claude, right? And the reality is different models have different strengths. Different models have different prices. But the core judge, the core decision player in each and every single agent is going to be the brain. Once again, if I'm speaking too fast, right? If you want to ask a question, feel free. This is supposed to be it's a collaborative session. Don't let me run away all through. And the further you are appreciative, you're closer. That way, you don't have to shout so much. The second thing is the context. And in fact, this is probably going to be the core and most critical layer of optimizing the outputs of our agent. Today in the world, the whole concept of people saying they're AI engineers is anchored in one thing: context engineering. And context, just to bring it well, is what does the model see when it runs? We have a brain that can think and give you an output, but you get to determine what it sees at each and every single thing. And for some weird reason, just engineering what the model sees is the difference between a great agentic workflow and a very pathetic agentic workflow, right? So just being able to give the model the right context tends to build in a lot. And then the final thing is a word, even I don't want us to talk about it from that word's perspective, but a lot of people will call it orchestration. So how do we make this system trustworthy? How do we make it reliable? So this is when we're now starting to build for production, right? It's one thing to demo a CV agent. It's a different thing to have a CV agent running in 100 different companies, right? Being called each and every single minute. When you talk about orchestrations, you're talking about that sort of reliability when things are going to be happening without you having whatsoever touch at any given instance. Okay, so let's start with a recap. In the previous session, we looked at the agent, and I'm going to summarize the agent into this particular layer, right? Typically, an agent has a goal, right? But for us to give it great, to get it to achieve the goal, we usually pass additional context. For example, in the CV example, the goal was you want a score on whether this person is fit for the job or not, right? And what context are we passing? The CV of the person, right? The scoring framework, right? Why is this person an elite versus that? So you guys have a scoring framework in your company. The third thing could easily be the job description, right? Anything else you'd add there? Anyone? Probably a cover letter, right? Probably the email. You know, there's a lot of things you could add there. And all this, we're starting to talk about the context, right? The second thing is the model. In the previous one, you were saying the GPT model will make the choice for you. So you've given it apt context about this particular individual, apt context about the company and what it's looking for. And now the model has enough context and it can go ahead and think and give you an answer. Then on the side is, optionally, your agentic workflow can make certain actions or requests. In the previous workflow, the tool was it can send the human and lead with a score. Make sense? We'll talk about all these sort of things, but certain instances, other agentic workflows might have slightly more complex tool calls. Others might have no tool calls. But the core thing is an agent has an option to go ahead and take an action without even a human interceding. And then the final thing is we have the output. Now, if I leave it there, this is how agents used to be 2 years ago. But today, everything runs in a loop. I don't know if you guys have jumped on ChatGPT and you ask a very difficult question and you see it outputs the first thing, says it's thinking, and then it's doing all that. Previously, when people are building LLMs, so just like give an output, then you pray. Now, the typical LLM models give an output, they look at the output and ask whether the output fits the base goal, you know, and they rerun up until they have comfort that the base output is what's required, right? And in instances where the LLM does not do that naturally, you usually encode it in your agentic workflow, even as an instruction. I want you to keep running this, check your output up until you get something that's desired. Does that make sense? So like automatically the agent is judging itself and it's getting the base output, right? And this happens a lot when people start talking about coding agentic workflows. It's going to generate random code 1,000,000 times and run it and see whether it's fulfilling the objective. And the moment it fulfills the objective, then better. And this is fundamentally, this loop is fundamentally the reason why today people say AI is great for things that, one, are not deterministic, which means like you can approach it in different ways. For example, marketing, right? We can approach our marketing in very different ways and achieve the same results. However, they're way better for things that someone can think and approach it differently, but the output is very finite. Make sense? Good example is when we are generating code, the code has to run to fulfill a particular condition. Does that make sense? If you're analyzing someone's financials, the final financial report, how much revenue you got, is a clear answer. There's no two answers about that, right? So when we have agents doing things that are naturally verifiable, they tend to be better because you have a natural test point for that particular agent. But I'm not saying don't use it for random things like creativity. It's still possible, but they tend to be fundamentally better at verifiable things. Even you as a human can come in, right? If I'm a doctor, get the agent to do diagnostics, and as a doctor, I can come and look at what the agent has said versus the symptoms and say, actually, that's verifiable. And those are things agents are becoming really, really great at right now. Okay, awesome. So now that we've remembered the anatomy of the agent, right, and I'm using that sort of CV guide as a good instance, where that loop is, it's going to look at the CV and keep running that loop up until it understands this is the ideal score for that particular person. And the verifiability is the person hiring can sit down and ask themselves, do these scores decide make sense, right? And if those scores make sense consistently, the more autonomy you give that agent. Makes sense? Let's talk about the brain. And the LLM or the model is the brain. And I know this is the obvious bit over here. And its only job is one, to decide the next step, right? I have a lot of my questions, I have a lot of my context, the model goes ahead and decides the next step, generates that particular output, right? Even if you're going to call it 16 times, at any given instance, it's just looking at the context it has and it's generating the output. So this is like our judge. But when you think about the brain, right now we have too many types of brains out there, right? We have different models, they have different strengths, right? What model, for example, do you use the most? I just want to make sure that at least you understand me. If you can mention a model that you use the most, yeah? ChatGPT, right? So we have ChatGPT. What other models are we using the most, right? For example?
So is Claude a tool or not?
That's a model, right? So that's the brain, right? It's the one doing the thinking very much. So now we are on the same page. I want to pick on people who have sat at the farthest back. So I'll just pick on you kindly. What model do you use the most these days? Yes.
I use Claude a lot.
You use Claude a lot, right? So we're hearing a lot of us are very anchored on frontier models, Claude and GPT, right? However, there's certain things. I know most of us are using models in subscriptions. Sometimes when you talk about agentic workflows, sometimes you start using them outside subscriptions. In fact, in most agentic workflows, you'll be putting an API key. When Marcy was here, she brought an API key from OpenAI, right? And that's what was being used to generate that particular output. She was not using a subscription. Subscriptions are meant for your personal use. When it comes to automated workflows, it's usually per call. Now, the sad thing about these API calls, and please ask me the question if I'm talking jargon, right? I'm happy to jump down to that, is one, costs are different. Cloud models are naturally more expensive than GPT models, right? Chinese models are fundamentally way cheaper than all these American models, right? That's a call layer. Now, if you're building an agentic workflow that's going to be used 1 million times, that 1 cent, right, multiplied by 1 million, right, is a lot of cash. So you have to think about the cost. Second is you have to think about the speed, right? If I'm doing an agentic workflow that's doing customer support, no one's waiting for 3 hours for customer support, right? But if I'm doing an agentic workflow that can code and build products, probably a developer can wait 2 days for a good output. You get me? So speed matters based on the task the agentic workflow is trying to fulfill. The third one is the judgment. We have models that are very strong, right? Some models are so great that even the American government is banning them from production right now, right? So just mute everything, the mic and all. Okay, awesome. So we now have models that are so powerful, even the American government is saying this is not supposed to be accessed. Okay, they say by non-Americans, but by de facto it just gets blocked for each and every single person. So of course, if you go take a small model, I'll even use, a lot of you are talking about Anthropic, there's the Claude, there's the smallest model, they call it Haiku. They say use that for things that don't need so much thinking, right? Customer support, not much thinking. This is my knowledge base, give someone an answer from there. And then when you want to do very complex things, like I want to do a business strategy for Zindua for the next 5 years, you'll go ahead and start using Opus, for example, right? These are all models by the same provider that have fundamentally different strengths and different judgment capabilities, right? And you don't want to overpump an advanced agent that's costly on a task that an low-cost agent with lower judgment but can easily give you the output can do. And the final thing, and what we're seeing a lot today, and I'll show you in a few, is specialization. We're starting to see agents have different specializations. Most of the people using these agentic tools, you'll go ahead and find someone has created a specialized agent purely for marketing. Someone has created a specialized agent purely for business planning. Someone has created a specialized, not agent, model, sorry, for coding, right? Someone has created a specialized agent model for writing, right? Some of us will come in and say, I don't like the personality of Gemini, I like the personality of this. Does that make sense? So already, that's not even a specialization, that's contextual. You already feel what you want to use something for versus what you don't want to use something else for. Law firms will come in and say, I've gone ahead and defined a model that's great for legal. So it's never going to assume it knows an answer when it does not know an answer, right? Because this is fundamentally critical. So specialization is something we'll be able to see in a few. I'll go ahead and ask, right? For those of you, because I know some of you have toyed around with this one, right? What models do you use for different? You can just tell me one thing you do in your typical work and what model you run towards more times than not. Scripting? Yeah. Okay, awesome. So we have someone doing a lot of scripting, and Claude is the de facto model for that sort of scripting. Anyone else? Thank you. Yes. Data cleaning. Awesome. Which model is it?
Like in Excel. So I use Log a lot.
Yeah.
So I can be able to pull, unless there is what a plan or share with me, and there is what I want from that Excel. So I'm able to give instruction to all the clone and tell it that I want this data to be outputted this way.
Yeah.
So it's a good.
Okay. Thank you. So still Claude. Now for data analytics. No one's using other models, right? Where are we not using Claude, right? Anyway, what do you use Gemini for?
Emails.
Emails.
Yeah, just the format emails.
Okay. Interesting. Gemini for formatting emails. I don't think the Gemini team would be happy that they just use for formatting emails. Who else? Awesome. Now, I want us to look at something, and in model pricing, we'll come down to that because I do want to look at this one. Someone online who wants to tell us a different model that they use. And I just want to reinforce the whole point, right? So there's people who created dashboards for being able to look at models and see their rankings based on certain benchmarks, which tends to be something more verifiable on why we're using certain things for certain things, right? A good example is you ask any developer right now, they'll tell you Claude is the best model for coding, but is it? Right? People who have multiple subscriptions will start saying something different. You get what I mean? So I'll go ahead and say this contextually. You can't believe this 100%, but it gives you a general flow of what's looking forward. Does that make sense? So one example is Open Router is a place where you can get API keys for any model. Yes. Zoom in. Okay, that's fine. So I'll give you this example. So Open Router, someone on the call is saying something. I don't know who can help me with the call. Screen is not showing. Are you sure about that? You can see it, yeah? So screen is showing. Just leave the call and reconnect, and then we should be good. So I'll give an example. This is like Open Router, and Open Router gives people APIs to use whatever model you want. Instead of you going to Claude and finding a key, going to OpenAI and finding a key, you just can't get one key and you have all models. None of us is talking about Alibaba models. There is Alibaba models at cents on the dollar, right? That you can use really, really well. And here they already start giving specializations. What are the models being used for text-based problems? What are the models being used for image-based problems, video, audio? I'll talk about embeddings in a few, which is also a different type of model. When I come down here to my comparison, right? Okay, I shouldn't have even gone on comparison there, because they also do like cost ranking as well as output ranking. So this is newest. I can come in here and I see for coding, we have models that are specialized for coding, right? And now let's go ahead and look at high to low. And at the moment, that firm will find that was banned is the best model, followed by LGBT 5.5 and then Opus. So for the longest of these ones available in the market, most people will say Opus, but in real sense, It's the codex one that's running. And if you wanted to save cost, you scroll down and you start realizing like a GLM 5.2 by CAI, which is based in China, which you can deploy by yourself, is also giving you really good bandwidth. And look at the difference in cost, $3 versus $9 here, 0.95 versus 1.5 on that sort of other end as well. So you're able to still see what models are specialized for what, and they're based out of that. And I'll just talk about it. So specialization is different. A lot of companies are trying to tune models to be specialized in certain things. Zindua will sit down here and say, we want the best model for teaching, right? And we'll try to tune those models to be great teachers. And great teachers will never give you answers, right? They'll ask you questions and make you want to understand something fundamentally, right? The same way, these top labs will want models creating different things. Claude will have Claude for finance. The model tuned for that is going to be more anchored for finance than other things. So specialization is not a thing most of us care about, but it's a thing that we need to start caring about more often, because almost every model out there is coming out as a mixture of experts, which means the certain expertise that it holds by default. Okay, now let's talk about model pricing, which is what will take me to that one. Models are usually priced in tokens. Anyone who knows what a token is? Yes. Almost similar. Yes, it's token usage, just like APLC. It's a unit, right? But now the reality is, a unit does not necessarily always mean a word. More times than not, it's like 3/4 of a word on average. So it's just like a set of characters form a token. Make sense? Some words are long, so it might be more tokens. Some words are short, so it might be less token. But in real sense, tokens tend to be attributed to the text size that you're putting. Make sense? For image models, tokens will be attributed to the image sizes. So probably it's going to be based on pixels, right? For videos, it might be the quality of your video versus the length of your video. So that's the core thing. So it is usage in that sort of regard. And LLMs price us in two ways. Input tokens. What do you think determines the input tokens? Anyone? Yes? The complexity, not really. It's not really about the complexity of this one. Complexity is done by the model. When you choose that Fable 5, because it's a high affinity model, frontier model, with better judgment than others, it's already by default going to cost more for the same tokens, regardless, right? So Opus will always cost more than Haiku, right? Opus might be $15 for a million tokens. Haiku might be $1 for a million tokens. And that price there, which is equal to the number of tokens, determines how well it is, right? So that's all that. Anyone wants to try it? Go ahead for it. Yeah. Yes. Now you're fundamentally right on that one. Input tokens is whatever you've given the model to see. Whatever you've written, whatever you've attached as an image, whatever video you've added there. So when people say you're being priced for input tokens, they're pricing you for the length of the input you've fed the model. Make sense? So now that we understand input, someone else can tell us what output tokens are. Yes.
The result that you want from
The result that you want from the model. Thank you very much. However, just to clarify, because these models are running in loops, it's not usually just the end result you see. It's everything that the model has written, even when it was thinking before. I know some of us have used model and then it's only thinking, right? And you see dots there, right? And you know it's writing in the background. Anything it's writing in the background that's not going to be produced for you because it's going to think step one, take step one to step two, step three. All that is still part of our right? So to summarize input tokens, everything you've given the model as tokens. Output tokens, everything the model has written, whether it is your final output or like sub-step outputs of that particular model, right? And when you come down here to these ones, you can already see the cost is very, very clear. I have 0.95 million. So this is $0.95 for every million tokens you put, right? And then you're seeing $3 for every million tokens it outputs, right? So this is definitely a cheaper model than a Google Gemini 3.5 Flash, right? Of course, it's going to be way cheaper than if we use the band model by the US government, right? We're seeing $10 for input tokens, a million input tokens, and $50 for a million output tokens, right? And keep in mind, the price delta on the tokens is based on model quality or lack thereof. Chinese model is always going to be cheaper, even if the quality is the same, right? But the core thing is, typically you want better models are going to be priced higher, so that worse off models, but prices are delta for yourself. So it's not always that definitive. Guys online, I hope we are still together. Second thing we need to think about, models are anchored on what I call a constrained optimization. What's a constrained optimization? We are trying to optimize the quality of the output, but at the same time, we are constrained with the size of the input. You guys get me? I hope that's English, right? So the constrained optimization problem, we want to get the highest quality output possible. All of us want to write the best email. We want to do the best analysis, right? You probably want to write the best code there is for that particular task, right? But the core problem is you don't have enough context or context window to feed everything you want. I want this LLM to be the best lawyer in the world, but I can't feed all constitutions in the world, right? And the reason is all these models, and we come down here, have what we call a context window. So when someone tells you they have a million contexts, this is the maximum input size you can pass on that particular model. You cannot pass that. Make sense? So it now leaves us with one thing. We have this really awesome brain, but we have to be very creative as to how we optimize the quality of our output in a very small context window. And I know a million is no longer as small as what we used to have 3 years ago, where people used to have 50K token window. Now it's increased, right? But just know that it's still not enough. At the same time, as much as it's increased, using more context does not necessarily mean more output. In fact, you might be bloating the model for it to hallucinate anymore. So as much as this can take in a million tokens, input tokens, it does not mean you should use a million input tokens. You should just use apt tokens to get the output. One, because you're going to be affected on the price. And second, you don't want to feed it context it does not need for that sort of base answer. Tuko pamoja? So far so good. Is it thumbs up katikati ama thumbs chini? You can be honest, right? Sawa sawa. I'm seeing a lot of middle hands, but thank you very much. All good. Guys online, I hope we are together. You can just give me a thumbs up if we are together. You can hear me. Thank you very much. Peter, ni wewe bado una clap online na in person? No, it's fine. It's all good. It's all good. Awesome. Now, if you ever want to analyze models beyond what you typically know, I highly recommend artificial analysis. They're called, they're given model access by these companies, and they do no bias analysis. So they pass it by benchmarks, and they go ahead and give you a benchmark of intelligence and all those sort of things. So stop listening to random people calling themselves experts on social media. Go look at actual verifiable tests. Open Router, because they give you APIs, their dashboards are anchored on the usage of people. I use Open Router API, so it's going to come in and say the most used model in the world is this, right? So it's always going to be anchored on the usage of people because they also offer it that. So if you want a low bias way to analyze models and understand the state, these are the 2 links. They're on the slides, but if you search artificial analysis or Open Router, you should be able to get it. One thing to understand, right? The priciness of your agent is anchored on 2 things. One, your context size, because your input tokens are very critical for the pricing. And then the sad reality is the loops. We said agents these days are working in loops, right? So the more the number of loops you have, the costlier the agent, right? For the same context. The larger your context, the costlier the agent. And all you're trying to ask yourself is, are you happy to pay more cost? Right? Sometimes you want to pay more cost for greater output, but at some point, why should you pay $10 more if the improvement is going to move from 92% to 83%? That's why we call it a constrained optimization. Okay. Now, this agent priciness now makes it even harder to analyze the dashboards because you'll find agents that or models that are known to have what we call they talk a lot. A good example is the Gemini 3.5 Flash. It might be cheaper than Opus, but it talks a lot. And all that talking a lot, you're going to look through it as well. So you're getting a cost thing there. But don't worry so much about that. Just use the source of truth from these ones. And as you use models, you'll tend to realize what's best for your typical output. Okay, so if I was to summarize what I'm talking about from a brain perspective, how should you pick a model? I think you should pick a model that's ideal for your base task. If you want a simple, repeatable step, so let's take an example, you're doing data extraction, or you're formatting a document, or you're just doing a simple classification, or is this a negative sentiment or positive sentiment? You get what I mean? Let's say we're doing customer support. A good example is customer support. Go use a small, fast, and cheap model. Find your haiku. Find your GPT, OSS, blah, blah, blah. Don't overpump, right? Don't pass fable to answer customers and with speed of 10 minutes per response, right? And cost that does not make sense. So the judgment one is for simple repeated steps, go for simplest models. And then for hard judgment, that's when you now go for those advanced models. When your goal is ambiguous, when you need very in-depth planning, when you have to think about multi-step reasoning, when there's this tricky edge cases to think about. A good example is coding agents really have to think so much, right? Or someone who's doing business strategy has to think so much, right? And in such instances, then we can advise go use those strong frontier models, right? Go use your Fable, okay? Your PESA, it's a bit hard, but you can use an Opus, right? You can go use your GLM. You can use that GPT-01, right? GPTs have the O models and they have the standard models, and it can give you that sort of output. And then there's models in between, and usually what I will say, by default, don't go complex if you've not tried simple, right? Try simple. If it's not giving you a desired output, you can climb up. And that's more critical for agentic workflows that are likely to run multiple times, right? It's okay for you to test out all these things when you're starting off, such that when it runs a million times in the future, you already know probably I didn't need such a small model, and probably you need such a large frontier model. I needed just a good sonnet model that's in between that. Make sense? And that's about the brain. Any question about the brain? Any question about the brain as I look at my time? Cool, we're all set on the brain. Let's talk about the context. Now, a lot of our output is going to be anchored on how great we can anchor the context. And the reality about the world today is almost all these models perform in a similar way. There's edge cases why some perform better than others in very minute ways, but the reality is that's negligible if your context is the right sort of context, right? You can achieve the same results with Gemini as Claude, as with a Kimi K2, so long as you've engineered the context really, really well. Don't get me wrong, some really advanced models can think for you, and fill the gaps that you've ignored, but most models when tuned well will give you the right output, or close to the right output with a very small delta in between. There's only one rule we talk about in data and in each and every single thing. If you're a data analyst, you're always told garbage in, garbage out, right? If you're a data scientist, you're told garbage in, garbage out, right? That's standard, right? You feed garbage to your brain is going to produce garbage. Even for us human beings, right? What you've consumed as a kid, if it was pure garbage, that's how you speak. I'm not so sure about that. But the reality is that's the base structure of our models on this sort of thing. And because context speaks so much value, anytime you hear someone saying they're an AI engineer today or they're an applied AI engineer, there's essentially, they're just talking about the art of context engineering. They're literally just telling a model what to see in the simplest terms, right? So the next time you go for that mixer and someone says, oh, I'm an AI ML, they always add a million things, AI ML plus IoT, blah, 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 all those, right? Just know just ask them. All you do is just tell a model what to see. Even you can do that with a prompt. Make sense? So all of us today are AI ML engineers. The moment you can write a prompt on ChatGPT, just don't call your expert here, right? Cool. Let's start here. The simplest way to context engineer is prompt engineering. It's the simplest, highest value way. We always say use the simple things that give you the highest value. All the things that we talk about down here do not matter if your prompting is not great, right? Tool calling. at what instances do we decide to call a tool versus not call a tool, right? That's an art of context engineering. Memory, and I'll just think of agents like a human being, right? You can come tell me, Cyril, I want you to go do this, that, right? But you're assuming because you told me that the type of thing you want me to shop for yesterday, like let's say you prefer green over red, you're assuming I'll remember, right? So there's always like that sort of big assumption. But Cyril knows I like color green. So if I send him to buy me sandals at the supermarket, so the prompt is go buy sandals at the supermarket, right? I'm supposed to remember that when I see a lot of sandals, I choose the green one, right? So there's a memory element to this. Now in agents, what's the memory that's persistent in this agent? What do they always remember at any given instant? It's only part of the reason why some of us use GPT and you feel like it remembers you so well. It remembers your birthday. It's telling you, oh, from the previous chat, you told me blah, 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 right? So it's, psychologically, they've engineered the memory really well to understand your preferences. And then there's something that people usually use a big word for. They throw acronyms, they call it RAG. It's very simple. Retrieval is the word, and what we're trying to say is when we have a really large knowledge base that cannot fit in our context window, how do we determine what part of that knowledge base to feed to the model? Make sense? So it's not a complex tool, it's just I'm trying to choose the right piece of my really large database to feed to the model. And then the final thing now is, now this one, some of us, we just have to get humble. These are the people who now fine-tune models. The person who says, I took the Opus model and was able to retrain it in a lot of code, and now it's a coding model. Does that make sense? So this tends to now be the advanced one, where you see a lot of these big companies trying to do for specific tasks. But all these advanced things are becoming very accessible to all of us. So it's always worth to keep out the lookout because people are building very simple tools. So I hope I'll be able to answer the question we had from the first phase on prompting. Prompting is very simple. These are the instructions you feed a model. Okay, so we are used to interacting with ChatGPT and Claude, so that means we are always just feeding in our charts. But the reality is when we talk about agents, we have to mix two types of prompts. One is the system prompt. You as the agent owner, what instructions have you given it? And the second thing is what the user is going to come up. A good example is in Mercy's agent, the system prompt was, this is my job description, this is how I want you to do score. And the user prompt was the CV and the email they write. Make sense? So every user will come with their own thing, but this other system thing sticks the same regardless of the business, right? So prompting is the core thing. But it's the same layer. Even when you use ChatGPT today, you're not using a raw tool, right? You're writing your prompts, but ChatGPT has system prompts telling the agent or that chat how to act, right? It's telling, I want you to delight this customer by remembering the preferences yesterday, right? And encoding all that. So they already have a system prompt running down. When you say you want to hack the government, they already have a system prompt that says, when someone tries this, and that, tell them you're not going to give an answer, right? And those are some of the core things that have been done in the backend. So let's take an example of a bad prompt. Bad prompt is we have someone who sent a message, so we have a user message, and then you tell it to reply to this customer. Bad example, right? But we can come in here and say, why is it a bad example? We don't know the role, right? Who's replying to the customer? We have no limits. Do you want me to reply in 3 words or 300 words, right? Or 3 pages? We have no idea of what good looks like. Probably we are going to curse in that sort of response, and still verify you reply to the customer, right? There's no tone. What sort of tone are we setting? So that's a good example of a very, very bad prompt. And then you go ahead and see someone else build a customer support agent and starts telling it, you're supposed to, you're a support lead, right? You want to respond to customer queries. We want you to be polite. We want you to respond in less than 4 sentences. So you're not expecting paragraphs here, and only offer a refund if the order date is within 30 days. Now, this is my very first example at improving this bad prompt to a good prompt. But the core thing is, prompting is all about giving context, right? Can you tell the agent or the model what exactly you want in very detail? And this thing, as simple as it is as adding words, is the most valuable thing you can add to any agentic work. So what's the structure of a great prompt? I know Mercy had a free prompt engineering workshop that we did before. I don't know, Mercy, if you can share notes, we can just include it. All the prompting techniques that we had, the one shot, the zero shots, and all those ones. Yeah, after this, no pressure. I think we do have good guidelines for the prompting because this is a summarized one. I'll just go ahead and say the structure of a great prompt. One, define the role. If the model knows what role it's acting as, the better, right? If you tell me I'm a financial manager, already the model knows it's supposed to be very structural and logical as to how it's supposed to think. If you tell it we are a creative marketer, it's supposed to think slightly more creatively or experimentally. So the role is fundamentally important here. We have to tell it the task or objective. What's the end objective or the goal that you're trying to achieve here? We have to talk about the background info. Sometimes you don't give background info enough, right? You know what? We're trying to do this ad strategy. We've tried this, and that before. It has not worked out, right? What do you think could be the problems from those ones, such that when you're designing this ad strategy, we don't make the same mistake? Okay. Constraints, right? In our example previously, you said don't go over 4 sentences, right? Constraints might also be the format you want. I want you to do it in a Word document. That's what I want at the end of the day, right? Or I want it to only be 1 page, right? And I want it to be more diagrammatic. The other thing is output format, right? What's the format of the output? And even to make it even more reinforced, you can even go ahead and say, this is an example of what a great response would look like. Make sense? Now, you don't have to use everything over here, but you just have to feed enough context based on your actual needs. If you're very sticky about the output, then give the example in the output format. If you're very sticky about the background info and you don't want it to make the same mistakes you've made before, then be very sticky about that. If you're very sticky about what the constraints, how far it should go on certain things, be very clear. And then the final thing is, sometimes you just say, I invite you to reason. What do you think about this? Tell me. And then you can even reason in the model there before you get to an answer. In that sort of instance. I put that in italics because it's the one where you do multi-step. I prompt this way, I get an answer, I ask you to reason around this, I prompt again, right? So it's part of what we call prompt chaining, chaining a lot of prompts together. There's just one thing to remember, right? And the sad thing is, even people who are very, very experienced in the flow make this mistake. Prompt quality is a trade-off, and it's a trade-off between two things. The rigidity of your prompt and the vagueness of your prompt. And there's only 2 rules to follow here. Do not be too rigid, do not be too vague. Do not be too vague, reply to this customer. Do not be too rigid, these people who start even telling us, if this happens, do this, then if this happens, do this, then if this, what's the whole point of our model? If you're going to give it if else's, go write a script. And let it be determined from the get-go. If this, then that. If this, then that. If this, then that. The whole point of models is they can think and make those actions together. And these mistakes, I see. I don't know if any of you have seen the whole craze around skill and bees for cloud code. Anyone? Anyone who's playing the skill and bee? I know we have our workshop that's going to cover a lot of those ones. You go ahead and open a skill and bee, and it's giving if-else statements on how to generate a PDF for a model, and you're asking, is this worth it? Ideally, if that's a skill and I'm supposed to have on my computer and pass from model every time, it's not valuable. I'd rather build that tool once, right, and always run that tool each and every single day. So never be too rigid. Give it enough flow, and at the same time, don't be too vague, which means you're not giving it too much context. There's a right sweet spot in between those two things. Any question? This is probably the best time to ask a question because this is the lowest effort thing that gives you 80% of the results. Yes. Yeah.
Where they do this sort of prompt engineers.
The role.
Where they usually
Where? Which companies? I feel like prompt engineering as a role is no longer a role. It just feels like all of us are using AI day to day. You need to be great at prompt engineering for your particular use case, right? There used to be a time where people who are trying to call themselves prompting experts. And this is why I always say in the gate, in a field that's moving at the speed that it is, Like just avoid branding yourself something and then next month it's gone, right? I'm not saying prompting is gone. It's just like now the structures of people are saying put a title of these are the instructions. I know the models are smart, they don't even care about this. So, and all these top companies are trying to say, we want to build a model that it does not matter how great that prompt engineering, if you just pass the right context for your code, the model is going to be smart enough to do it. And let's be honest, right now we are there. So the role prompt engineering, I feel, is a dead role. If someone hasn't advanced to be a context engineer now, that's not a role, but ideally anyone in the workspace, just like typing is needed by anyone in the workspace, needs to be okay with this pattern. Cool. Any questions? Let me hear from someone online. Okay, I'm getting crickets. Okay. Anyways, the art of teaching is the art of being able to absorb blue ticks. Let's talk about tools. So tools, just you're telling the model what can I do. That's exactly what tool calling is all about. And let's go ahead and act this out. This is literally what we call the acting node. Like it can take an action, right? And it's usually a door between your agent, right, and your systems. A good example is we have a really good agent, but we talk mostly on Discord. How can that agent interact with our Discord messages, for example, right? We have a really good agent and it needs to access our e-commerce data so that we can be able to respond to our customer well, right? That's a base question. If you say respond to this customer and you're saying, oh, my order did not come, it wasn't fulfilled, how is it going to answer that customer if it does not know the status of that order? So we need a tool to go take an action and come and give you a response here. There's two types of actions tool calls usually do for us. The first one is they retrieve data for us. They retrieve information for that model to be able to actionalize it. A good example, if I jump on GPT today and I ask it, what's the weather today? Do you think it knows the weather today? It does not know the weather today. The models we're using today were trained 3 months ago, sometimes even last year, right? There's no way they had insight as to the weather today. But what it does is it's going to call the weather tool, right? Those meteorological departments, they have their data publicly. It's going to call that data and go ahead and tell you the weather in Nairobi. Now it's using memory, right? Because you're in Nairobi, it's telling you the weather in Nairobi is that, right? Even with a very bad prompt like that, these people have engineered it in a way that we have a tool and we have some memory to give you good context. Make sense? So retrieval is very important. I'm trying to build an agent and I want it to book a slot on my calendar. So it has to access my calendar and know my available slots, right? Or I'm building an agent and I want it to know the order, whether it was fulfilled or not, right? So I want it to query a database and get an answer. Or someone is telling us, I want to go ahead and understand how much revenue this company made that particular day. Or let me bring it back home. How many active users does Zindua have on the learning management system, right? We're trying to gauge whether we have students actively. Even I can't answer that. We have to query a database and get that sort of answer there. The other one is web search. You have an agent that can go and say, search the web, find research, and get all the articles that can help you answer this question. Then use that as context. That's an example of retrieval. Give me examples of things you'd want a model to retrieve for you in your agentic work. I want to hear from people I've not heard from. Yes. Just any random thing. You know, we can do anything.
Probably identify for me like specific paper that would be tied to concept.
Awesome, that's really, really nice. That's a good abstraction of our web search tool, but now on Google Scholar, where it's only searching Google Scholar to give you vetted academic articles, for example. That's great. Awesome, let me hear from you.
So when we basically say about
How people are using AI as a 26. That also feels like a website. There's going to be a published report. Awesome, thank you very much. You know what? I'll save you for the next question. Don't worry, yeah? No pressure. So just be prepared. Anyone else? Let's hear from this table. I've not heard from you. Any tool you want your agent to coordinate when it's doing something? Okay, someone else from the table who can bail him out. So we have apt responses, no pressure. The second thing tool calls can do is they can act on your behalf. Now no longer, it's not just about a model giving you an answer and telling you now go copy that or why. Now the model can take the action on you. If you tell it to generate a Google Doc and even add it on Drive, you have a tool call that can actually save something on Drive. We're seeing that with typical chat tools today, right? Even the agentic workflow should be able to do that. A good example is the moment you're done here, send the email. Send me the email or send that person the email. We're not waiting for anything here. That's an action it can take. The moment you're done here, trigger the payment. I've seen someone who's built a full ticketing business on anytime with agents, right? It takes the tickets, queries, and sees whether there's available resellers to do that sort of ticket. When the resale happens, if no one had a complaint or do it's going to trigger the payment the next particular day. And you have an agentic scaffolding that's looking at data and making certain actions their own flow. Anyone with a different example of some actions you'd want your agent to take? Let's think about it. Imagine an agent you're doing the first session, how can you start actionalizing it?
Being able to take a business processes, and being able to
I would put that in a demo. So now you're probably talking about the tool code, because agent is going to do a lot of the synthesis and judgment and the thinking. Now the tool code would be the slides. Yes. So now you have like a generate slides. So it's a tool called for PowerPoint Creator, for example, right? So when you talk about a tool, it just means like this is an external tool that already can fulfill a particular thing that an LLM can talk to fulfill that. For example, what is the weather today? The LLM goes to that tool, asks it what's the weather, the tool gives it the weather. In this sort of instance, the LLM gives these are my slides, right? Bit by bit, or it can even create slides through that tool, each and every single thing, because it's not like PowerPoint is on the model. Does that make sense? So yes, there's more advanced tool calls, for example, like a PowerPoint slide is an advanced tool call, and there's simpler tool calls. For example, currency converter, right? I want you to convert this currency from this to that. However, I have a tool that already has the currency rates that I'm using. Make sense? Okay. Thank you very much. That's a really good call there. Let's talk about the different abstractions of tools. Today I've talked a lot about, I thought the second thing was the first item. Sometimes it's just a predefined function, like what is the weather today? Or calculate 2 plus 2, right? You have a mathematical tool for it. I know models can think like that, but to avoid hallucinations, you can tell it anytime you have a mathematical thing, I have this function that I've written that can do that modulus. Make sense? To avoid those sort of things. Second, it could easily be an application programming interface. An API is just a way for applications to talk with each other. For me to get the weather today, there's someone who's created a weather API. So I can just ask the API, what's the weather today, right? For me to talk with Zindua's learning management system, there's an API, right, from which I can call, create a lesson for me, right, create all that. Right? I know some of us here are developers. We understand APIs very well, right? But a lot of times we talk through APIs. If you're in these circles a lot, you hear people starting to scare you with the word MCP, right? And now, the more the acronyms, the more you call yourself an expert. But that's not the core thing. This is just like a protocol. It's a standard for how different applications allow agents to talk to them. So it's like a document that's being written, such that Canva has written its own MCP. Now, when you pass that MCP for your agent or model can talk to Canva. Does that make sense? So don't be scared by the acronyms. And then there's other people who graduated from MCP and they started saying A to A. I'm not using MCP anymore, I'm using A to A. This is now still another protocol for you to know what times where your agent can tell another specialized agent to do a particular thing. Why does this matter? In the final slides of this sort of workshop, I'll show you how sometimes we break down agents into steps. So sometimes we need agents to talk to each other, sometimes we need agents to talk to applications we're using. MCP is just like a full document saying Canva, this is what you can do on Canva, this is what you can do on there. And then it understands the capabilities and queries those capabilities because that company has created the capabilities for a model. These days, even login, we are allowing models to log in without necessarily putting an email and a password. There's a different way to verify that the model is owned by someone. So that's likely to be a login MCP, right? So if you wanted to access your account, probably it should not struggle on the screen, and then it can't choose what's a fire hydrant. Apparently, the test of whether you're a human is how many fire hydrants you can click on, right? And if it can't do that, that becomes a big problem. So now with MCP, we bypass that, and models are able to understand how to query for certain things as well. The third thing is usually code sandboxes. There are certain restrictions where you don't know a tool, but models have become really great at generating code today, that if you just give it like a place to run code, it can give you a good output. A good example is earlier this year with someone who did research, and they said, all these people who are saying MCP, 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 and then they pass 50 MCPs on an agent, were getting way worse output as telling the model to just generate code to solve that problem and run it, right? I'll talk about that problem in a few. But so at times, applications define how to work with agents, but at times you can just go ahead and tell the model, I want you to write the code, this is the tool for where you can run the code, get output, give me the answer. Makes sense? Probably I don't have a weather tool, or I don't have a math tool, so it writes the mathematical code to solve my question, and then it runs it in my sandbox and brings it back to me. Keep in mind, you don't need certain complexity here. You only need the things that are relevant to your particular workflow. Yeah. Okay, just like in prompting, this is the core thing to understand. Context windows have what we call a law of diminishing return. The more you add does not mean the better it gets, right? Means the more you add, the value of that addition reduces, right? Up until it reaches a point where the more you add, you're making your output worse. So there's no point of you having 40 tools connected to your agent. Even I, as a human being, if you gave me 40 tools that told me solve this particular task, I can't tell what tool to use. But if you only gave me 5 tools, all of a sudden I'm very well set, right? And the same applies to agents. Always go minimum and don't create bloating at that context. Yeah. If we want an agent to generate slides, let's give it the slides tool, let's give it the planning tool if you have something else, let's give it a tool to get the actual data, but don't throw 40 tools at something because you want to do like you've context engineered, right? Context engineering is about choosing the right context that goes into an agent. Any question? Any question there?
Yeah.
Yes.
Can one agent handle a line of tasks? Like, use one agent, can you give it instructions to code? The same agent is also dealing with your customers, like interacting with your customers and all that.
It's possible, but it's not advisable, right? It's better because once again, remember the context problem we have. If I wanted to create an omniscient agent that knows everything, right? The reality is your context is likely to be very large. So imagine when someone comes and makes a customer support query, but your agent also knows about finance. All the context you asked for customer support and finance, they're going, and who you're being charged for all that as well. And now all of a sudden your context is very bloated that your agent is likely to hallucinate around this particular. I know we have smart models, but it's just usually way safer to pass enough context for each other. So in such instances, which is the final slides, can you break down a very large agent into subagents, right? And I'll talk about some of the small parameters that are there that you can try out, right? And it's a good code. It's possible, but it's not advisable.
So, like if you're coding, you need a coding agent. You also need to push marketing. You need a marketing agent, and all that. That's it.
Yes. Sometimes even the marketing agent is broken down into some agents in marketing, right? Now it's very contextual to your problem. Probably with the marketing agent, the context used by all agents is the same. So I'm happy to have that agent do each and every single thing, right? But the moment I realize I'm bloating my agent, I'm passing 40 tools, right? I'm using 100,000 tokens in my system code, right? All of a sudden you start seeing we are stretching the bounds of that particular agent. So I would say, at what point do you start breaking off and say that's too much, right? The moment you started passing a full book of 30 pages, and doing it as context, it can fit the window, but is it really the right way to hold the context? So you as a human being make the call because you understand your domain better than anyone else. And from my point, I'll just go ahead and tell you, any info that you pass there that's not relevant for the day's output is not. that either reduces your output quality and increases your cost. Okay, let's talk about number 3, and here I'll start going slightly faster because they're not the ones that we can rationalize all through. The third layer is what we call retrieval. Now, remember the case where I told you we want to create an agent that understands all the laws of the world, right? And can answer any legal question. We can take it to court tomorrow and it does everything for you. Heck, would we want to have an agent like that? But now the problem is if we combine all constitutions of the world, plus all the acts of parliament, and then we throw the finance bills and all these random things, and then we go ahead and do bylaws and all those sort of things, all of a sudden we end up with 1 TB of data that we really cannot pass in that sort of small context window. The whole concept of retrieval is how can we get an agent to just access the relevant bits of information, right? Question? So in this instance, you ask a question, before the model answers, it retrieves. It goes to the knowledge base and finds what part of my knowledge base is likely to answer this question. So if someone said, you know what, I want, what's a good legal question? Anyone who's a lawyer? Someone give us a legal question. Someone who's not taught. Let me give you a chance to say something. I will say something. Legal question, something in your mind.
Okay. In terms of environmental law,
You've gone complex. Nice way to read it through us, but go ahead.
what are the aspects that can have legal problems with the environment?
Okay. Once again, that's a large question, and you're asking this question from Kenya, right?
Yes.
Yeah, from Kenya. I want us to understand this retrieval thing. Imagine our knowledge base has all laws of the world. It has all laws of Kenya within those laws of the world. The first thing when you ask that question, all laws of other countries other than Kenya are irrelevant. Make sense? So the question is, can we filter them out? The second thing we have to understand, all these things about business law, family law, criminal law, all that is irrelevant. The only piece of thing we want from our knowledge base is environmental. So our core goal is, can we get this model to retrieve the environmental context from our database? Make sense? That whole thing is what people do fancy acronyms for and call retrieval augmented generation. Retrieval is just the art of having a large knowledge base and getting a model to retrieve only the relevant sources before it generates your answer. And that's the general flow we have there. We do have a lot of RAG techniques, which I don't want to talk about today. RAG is a very deeply researched science. It's probably the one place where there's always a scientist releasing a paper every single day. If you ever get to being a context AI engineer, you're probably going to be reading these papers more than anything else, right? Because all of us are struggling with how do I feed just the right context when my knowledge base is really, really big. The typical way we are used to working with RAG is what we call vector databases. Once again, you can shut off and ignore everything I'm saying right now. A vector database is just like a database where things are saved semantically. So if it's environmental law, imagine this whole space, imagine this whole was a database. Anytime we get things on environmental law, they'll be on this section of the database, right? And then things that are so non-environmental, for example, all the laws around oil and fracking and the things will be on that particular end. Does that make sense? So this diagonal dimension represents environment as context, right? Probably things pertaining business law would be here. So imagine if this was just like a database space, because things are stored like in vectors, different contexts will be stored in different places based on the semantics. The databases we're used to are usually transactional, but in vector databases we're using semantics, so we're using the meaning. So what usually happens is I take a large knowledge base, I break it down into small paragraphs, right? And then I go ahead and understand the semantic meaning of those paragraphs and throw it into the right place of my knowledge base, right? I don't want to talk about the techniques right? So when I say semantic embedding, it means throwing it into the right place of the vector database. And now, when you ask me a question, what I'll do is I'll take your question, understand its semantic meaning, and go to the right position of my database and find all the documents around that area that are kind of related to your answer. Does that make sense? Tumeelewa, right? I've explained it in a clean way without throwing embeddings and vectorizations, right? Cool. Any question on vector databases? This is what people have called traditional RAG. It has been the standard way to work with really large documents. In fact, even models today, I know we talk with them in text, but do you know that your text is also embedded and vectorized? In fact, if we just talk about fun facts, every word in the English dictionary can be represented as a vector. And in that sort of vector space, you go ahead and realize one thing so that you understand how models get meaning. If you do the vector subtraction of king minus queen, you're going to get an equal answer as boy minus girl. You guys get the context here? So we can convert words into numbers such that when you do the subtraction, you can see a subtraction that means gender. Does that make sense? So that's for words, and now we can do it for large chunks of context, and people can do it for images, and we can do it for videos. And we let all those people working in those companies do all the heavy lifting. We just get to use the tools as much as we can, right? So when you talk about vectorization, in the world, all words in the world are categorized in a vector with 10,000 dimensions. So apparently you only need 10,000 dimensions to encode meaning of everything. That's what all large language models are using. In our vector databases, probably we only need 1,000 dimensions, right? Sometimes you have inanimate objects. Is it human? Is it not human, right? Is it male? Is it female, right? Is it green? Is it red? All those things are going to be embedded there. And we don't usually know how, but the core thing is we figured out a way to embed context that we understand as human beings into context, models understand as numbers. Make sense? That was just a fun fact, but just remember we chunk data and we save it in the right spot of our database based on its meaning. The second thing is knowledge graphs. Once again, I don't want to talk about the technicalities. Knowledge graphs just means if I'm Siri, you know very well I'm Kenyan, you know very well I'm one of those people using acronyms and calling himself an AI ML engineer, right? So the moment you come to Siri, this node, if you ask question, AI ML engineer, we have someone pointing you to another node that talks about AI ML engineering. Does that make sense? Probably people hear one called lab, and it points you to the right point with retrieval augmented generation. Graphs have always been a programming paradigm that makes it easy to find information. So by knowing one source, you can easily route the different sources based on connections, right? A graph is really like a dot connected by lines. Make sense? You have a question? So I won't go deep into this one, but knowledge graphs are one way where sometimes when you do semantic embeddings, we use the relationship between things. Probably me, Siri, will embed me there on the vector database, but I have a relationship with Kenya and we are very far away. So if you wanted to answer questions about Siri and why he reacts like this, probably it's a Kenyan culture thing, right? And Siri is there and Kenya is here, and you will not answer it really well. But in a knowledge graph, Siri is connected to Kenya, so the model also will go to Kenya to get additional context. So me, Siri, as the center node, I'm able to connect to all the context around that. Zindua as a coding school, we can connect it to a node about coding schools. We can connect it to a node of companies with red logos and characteristics of those companies. Connect it to a node to companies that are around GTC. I don't know if we can be around the same vector database with GTC companies. Okay, very, very, very interesting call. Cool. Some of my jokes always go off. And then the final one is what we call, I swear, I'll be very honest. I tried looking for an English one. So just allow me to explain it because I know 920 does not do it. But these days on our computers, we have a lot of folders, right? Different folders have different contents. Different files have different contents as well. So instead of us doing all these complex things, what if we just summarize our documents with a small summary up there and say, when you go to this folder, you'll find all the strategies all the descriptions of programs for Zindua, for example. Imagine you're thinking of Zindua, they have a folder called programs, they have a folder called marketing, they have a folder called finance, right? So these folders already are anchored, just like you as a human being, based on things you typically do. When I go to the programs folder, the programs are named data science, software engineering, and even at the top of the document, there's a summary. In this document, I'm going to break down the curriculum, the this, the that, the that. Now, all of a sudden, when I have a really large knowledge base, I am not passing all the full knowledge. I am telling it, this folder has this folder has this folder has this. When you go to those folders, the first 5 lines of each and every single file explains what the file has. So now instead of me passing 1 TB of data, I'm just passing the base descriptions of files, and the moment the model finds the file that it wants, it's able to get deep into it. Does that make sense? And within those files, I can point to other files to say, if you want a more in-depth, broken down curriculum, go to the curriculum folder, right, / this file, and you'll see an in-depth curriculum. Here I'm just talking about an overview. In fact, this system of retrieval is what is powering coding agents today. Coding agents are not using semanticness. Some of them are using graphs, but a lot of them are more like, hey, I want to go ahead and create a cart, right? And what it's going to is it's going to your front-end folder, and it's opening this file, and it's saying, this is where front-end code was written, but now it has to interact with the database, so it looks for a database. You get what I mean? So a lot of the agentic tools we have are using this system. And I'll go ahead and say, this is probably the most powerful system and what's becoming a standard for where we go in regards to retrieval, because we have really good standards and we can easily summarize files into small descriptions. So 1,000 files can easily become 1,000 lines, right? Instead of 100 GB, very simply today. That's what models have learned the art of doing, because they can run commands on our computer. Any question? Okay, I'm about to finish, so come on, Jai, answer, just hold off for like 2-3 minutes, right? Cool, but I hope you're hungry for knowledge. The final thing is now memory, right? Memory is now what does the agent remember? Remember when I said how GPT plays us the game, it remembers what you did yesterday and all that, right? If GPT can remember all that, please don't use a Facebook model, because it might remember things even from your post. I'm not so sure about it. But the first thing about memory is what persists in the agent's context. Sometimes it's just user preferences. I like minimal things. Don't go through color. Make it black and white, straight to the point, no extra words. That could be me. Probably that's not you. Probably some people want to be told, hey, uko vipi, you want to interact with the agent. You want to have like a polite chat on that one. That's fine. Sometimes it's metadata. If we're doing an LMS agent, the metadata is this person is enrolled in data science. Or let's say we're doing a learning management system for high schools. You want to say this is a Form 1 student. You cannot answer a Form 1 student or even a Class 1 student the same way you answer a Class 8 student, right? The context they have is fundamentally different. That's memory you have to encode. Sometimes it's global guidelines. How many of us said we're using Claude? You go to your project description, it's asking you to encode instructions. It's asking you to upload files at the project level. All the charts you do underneath will be using the project memory as the core thing. Sometimes it's decisions and progress made. Remember when I told you that knowledge-based system for files is becoming very, very critical? Sometimes your model can easily write into those particular files and add additional content that you can call in the future. But sometimes just decisions and progress made. Oh, previously we said that I only want to use red, but now I want to change to green. Let the model have memory that you're changing from red to green. And then the second question we usually ask ourselves in memory is what happens when a context window is hit. Now, this is a problem we're trying to solve even with the Zindua LMS, because we get to a point where someone has been asking 100 questions, right, on the same chat, and we hit the context window. How do we answer while still wanting to maintain memory of all the previous things they've done? That's a big question, right? Are we going to compress it, or are we going to just call the chat and query the relevant ones? Does that make sense? So it could be you guys are building agentic workflows where people are asking the same questions multiple times in threads, and you just want to, at any time, don't bloat your context, just call the chats that matter. Or can you summarize 100 texts into one paragraph? and say this person was asking about this and this is how I answer. Cool. This one I will not talk about, but if you ever go beyond agentic things, fine-tuning is out of scope for us. But it's how can we embed knowledge into a model? This means we training a model. We take a model given by OpenAI, we pass our own data. A good example is we pass, this is how students ask questions and these are the great answers. And we want to teach it to answer like a teacher. Make sense? Out of scope for us, but it's just worth doing that kind of stuff. Any questions for us? Those are the 5 elements that go into building an agent. And I want to make it practical right now with clear examples so that it starts making sense. Any questions so far? Okay, give us a question. No question? What was not understood, or scale of 1 to 5, do you understand what goes into an agent? 4, thank you. So I hope we'll fix the remaining 1 here. In fact, I think the best way to fix the remaining 1 is, I want to skip some of these things, right? Here's your answer to your question, if you don't mind. I didn't get your name. Peter. You're Peter, yeah? Here's the answer to your question. When it comes down to now actionizing our agents, we have to think about how that workflow can be created. The first thing to think about is sometimes we do, instead of one agent, we create multiple agents. And we always say multiple focused agents are greater than one omniscient agent, right? We don't need one all-knowing agent. There's different ways to break down agents. Sometimes it's a sequential pipeline, right? I want you to read this document and summarize it. Then agent number 2, from that summary, now do this for me. Make sense? That's like a sequential pipeline. Every agent has a step. There's a clear handoff, right? You design the curriculum for the program. The moment you're done, the marketing person will come and figure out the outcomes for that curriculum. And that outcomes, this designer is going to create a poster. Right? Now we can do it for agents. The second way is to do what we call an evaluator optimizer. This one is more adversarial. I want you to write this document about blah, blah, blah. Let's imagine it's a blog. And then I tell another agent, I want you to grade that blog. Is it good or not? If it's not good, tell that agent to go generate a blog. If it's good, you can post it. Make sense? So this is a really good way to get out. It's about how you verify as well. You don't have to take photos or anything, you're going to get the notes all through. The third one is supervisor approach. You have an agent that's a boss. Kazi yake tu ni kukaa hivi na kusema, you do this, you do this, you do the other one. In fact, the supervisor approach is we give it a problem, it plans and breaks it down into different subcomponents, and then assigns to different agents, right? Hey, we want to create a multifaceted business strategy spanning marketing, spanning what else? Sales, spanning what? Product. So it breaks down and says we want marketing, I'm going to give this agent to just worry about marketing. You see how we are reducing the context that's going to go to the sub-agents? That's a good way to think about it. And I'll show you an example. The other one is a person called a concierge. Who knows what a concierge for a hotel does? Okay, I should have used Kenyan examples. Even I don't know what a concierge does. But what I think the concierge does, right, is you go to the hotel and you say you want something, and it will route you to the best person to do that, right? So it's more like a specialization. So there's always one person that you talk to, and that person knows who specializes in what, right? You get to a kitchen, and there's this head chef. Na kazi yake ni oversee all the dishes you're going to cook that particular day. So when you say you want eggs, there's a chef there that's specialized in eggs. When you say you want fried rice, there's someone there who just does fried rice. Here, for orchestrator, they plan and break down something for different agents to do. Here, they're working with specialists. So we have an agent that is a specialist at doing slides. Here, you don't just want to give anyone to do slides. Here, everyone can do whatever. But here, that slide has to be done by an agent that understands design more than anyone else. Make sense? So that's a different way to think about it. And then the third and final one is what we call like a parallel swap. This is like factory. All of us are factory workers. We're trying to do the same thing, right? We do this a lot in coding, where when you're doing code reviews, different agents will be given different things to review, and they all do it at the same time. It's a good way to improve speed for very large tasks where people are doing the same things. It's like everyone is trying to approve its own sort of layer. So sometimes one agent is not the best approach. Sometimes we break it down into steps. Sometimes we want it to be evaluated. Sometimes we want a supervisor to assign things and plan. Sometimes we want someone who knows a specialist. And other times we just want it to be done collectively by multiple agents. And you can even gauge. Sometimes it's teamwork. Sometimes it's adversarial. You come and gauge agents and you punish the ones that didn't perform well. I don't know about the punishment there, but you can choose the outputs that make sense. Second thing is we always trace and evaluate our models, right? Tracing is the art of any question that someone asks a model, you make sure it's documented, right? And you'll see this in agentic workflows where you just add another API that's called a tracing API, where any question that comes in and the output, it's saved somewhere. At the end of the day, you have a central source of truth. This one I'll show you practically. Cool. I'll show you practically as we come down to this. Okay. The second thing about tracing, about evaluation is we can also do A/B tests. Sometimes we don't know what prompt is the best one. We'll go ahead and say for 50% of the times, try this prompt. The remaining 50%, try this other prompt, right? And over time, you'll be able to see what prompt is the best one. This is only possible if you are tracing. Make sense? And then the final bit is now what we call, can you tune parameters? So sometimes we want to change the model from Claude, right, to this, right? Sometimes we want to increase the advancement of the model. Sometimes we want to reduce the tools or increase the tools. There's a lot of parameters that are happening in this model that you can always adjust. In fact, this is the moment your workflow is starting to be used by multiple people. I highly advise you start investing in being able to evaluate your agentic workflow. Cool. I don't think I want to talk about this particular slide. It's good for developers. It's not good for the rest of us. Okay. Cool. There's just one thing that I want you to go ahead and see. When you talk about orchestrations, this is something I've built on. There's one paradigm that's starting to be over the world. What is the paradigm where we're building agentic workflows? Can you get it to work alongside humans, right? The core question is, can you get the agent to populate the same data set that humans are working with, right? If your agent has access to Notion, and that's why you write documents, when it does particular work and it does a strategy, it goes back to your Notion and updates your marketing strategy there. Now, all of a sudden, we stop having instances where we have context for agents, context for humans, and interaction is only through prompting. And all of a sudden, now we have a central spot where we're doing work, where all of us can do work. Now, the achievement is we can now have agents working alongside you. Now that you're building a visualization on a piece of data, and your agent is doing another sub-visualization, and all of you are populating the same sites, right? Probably for developers like Haley here, right? You are writing code on one piece, right? And you have agents writing code on a different piece, and everything comes together. All of a sudden, you finish 3 features in one day as compared to one. We are talking here about saving time for ourselves, right? And getting the most output. One way to do that is to stop separating agents from us and bring them together. That's like a paradigm you should try on any time. Feed the tool code to go add the same data that you interact with, right? Of course, with good guardrails. Lambda medical data is not where you want that to happen 100%, but in strategies and things of that sort, it actually could be to your benefit. I want us to look at a couple of examples here of agents, and then you guys will tell me whether it starts putting everything you've covered into context. Makes sense? So I talked about a sequential multi-agent workflow. Here's an example of, we have a client called Verge Advisory. They wanted to transform their consulting workflow into an agentic workflow, right? That's a base example. So their core goal was, we're spending so many hours, in consultant hours, in transforming a transcript into notes, diagnosing a company, getting recommendations. Yet right now we have agents that can think about that, right? This would take consultants 1 month. Can we bring it down to 3-4 minutes? And this is an example of that. We have, instead of having one agent that does everything, we break it down into an agent that does, give it a transcript, transform it into notes. And guess what's the guiding factor for this transcript? Verge already has guiding questions. If you want to gauge this company on performance, these are the questions we want to answer. Right? So that's our prompt. And this is the transcript from our client meeting called MBKX notes. That's a good example. The second thing is, the moment we get the notes, which gives us the state of the company, now we have another agent. The whole point of this agent is to diagnose the company. What does it take you? It takes you Verge's maturity matrix, right? It grades a company on different levels and tells you how good are you at performance management, for example. How good are you at hiring? So they have a clear rubric that they use on the guideline side, and now the agent can use that, right, in the company context to go ahead and tell you, hey, this is a basic company. Your performance management is basic, and these are the problems that you see. And then after that, we have another agent that can come in and take your diagnosis of problems, and now takes in still the same maturity matrix and also like a prioritization. How do they do scoring, which is also from that. And now what do? They recommend actions. Does that make sense? And then finally, we get the output, which is what you're going to present to the client. This output, right now is not slide, but in the future it could be slide. Probably we do an agent that can do a tool called here and transform it into slides. Let's see it in passing. Okay, so this is the example of, this is an agent that has been fed into a front end. Once again, you can still do it on any tech. Whatever I've done there, you've seen how we have steps. What you're doing is you're just passing context. But the only problem with an intern is you won't have client interaction front end. Does that make sense? But now when you do it probably outside the intern, you can have a client interaction front end. That's the only difference. But if you're working in your own company, do you care about it? Or do you care about just feeding the transcript, letting the workflow go down, and then you get reporting? Does that make sense? So this is not about trying to say you always have to have a front end. It could be anything. So here I had generated, if I just escape here, I had generated some random company, right? So you can see that's random company. And this is the notes it took on HR and strategic planning. So I hope I'll be able to just, okay, I think this is fine. Okay, so now, when we come to our agent, we don't have the transcriptor, the one that converts the transcript to notes. So we're starting from the notes side. So we can paste the notes. Ideally, these are the notes we've gotten from the transcript. And then we can press diagnose. And now the agent is going to go ahead and analyze the notes and now diagnose that. Does that make sense? So this is the first agent working. Its only goal is, I've given you notes, I want to give you diagnosis. Okay? So that's fine. We'll give you 10 to 5 seconds finish. We should have chosen a different model. Any question in the meantime? Okay, now all of a sudden it's given us an answer. So it's told us this company is very basic. So I don't know what we chose. We chose HR. I don't even remember what we chose. But it's level 1 on HR elements, and it even gives us the decision. So this one was tuned to give you reasons why you're at that particular level and your score. And then now we are asking this company, based on the matrix that we have, we know your basic, what do you want to be? Probably we want to be advanced. And now when we run the assessment, the other agent now comes in and takes whatever the diagnosis was, and it's able to give you like an action plan, which is the recommendations. Does that make sense? Any question on this agent? Is it clear how we've broken down like a very complex agent with multiple steps into individual steps? So they do handoffs. Huyo akimaliza diagnosis, then they recommend. Recommend akimaliza recommendations, probably give the slides agent. You get to me? And all that, right? So we'll just wait for the recommendations here, and then we'll see the output. Any questions? Comments? So, does it make sense? What agent are you thinking about right now that you've broken down into multiple agents? I can see the agents in the head. Right? Okay, so, and now we have the prioritized recommendations coming in as an output. And then the final output here, which is we are likely to put as an agent, is how can you export it as slides? Right now, you can only export it as a PDF, for example. This is a good example of a very simple agent. It's purely prompting right? And breaking down one agent into multiple steps. Does that make sense? And you can do it on any time. The second agent you're going to talk about here is what we have on Rukia Labs, which is the Zindua LMS that's now available for the schools. And this is now a good example of a retrieval agent. What is a retrieval agent? Because it can only answer students with answers from internal Zindua content, it has to show you where that answer was from. Does that make sense? Now let me talk about it diagrammatically here. When I come here, you'll be able to see this is what we call like a retrieval agent. So what do we have? A student asks a question, and when the student asks a question, we first of all have memory. The first memory we have is what's the level of this student, what program are they enrolled in. The second thing we're asking, are they enrolled or are they not enrolled, right? Labda amelipa, labda hajalipa. Right? That's probably like a client requirement. And then the third thing is now the inferred memory. Probably they've been asking about that particular lesson for a long while. So this is not the first chance. They're doing multiple chances. So we have memory and then we take the student question. Now when we take the question, we come here to the retriever, and what does the retriever have access to? It has access to all course content done by Zindua. It has access to all the approved books that Zindua has uploaded, right? To say these are good computer science books for you to use. And what this retriever is going to do is going to find what part of my database is going to answer this particular student. And the moment it retrieves the sources of the answers, then you can take the question and the sources of the answer and answer that particular student. Let's look at an example here. I had run an example just before when it started off. So a good example of a course that I happen to have been part of the curriculum is the data structure and algorithms course. And we wanted to ask what's the difference between a linear search algorithm and a binary search algorithm. And this was my question here, right? What is the main difference? And this is the answer I was able to receive. And you can see with the answer, it's able to come and cascade down and even give me the source. So the source is, it used the book Art of Programming, right? It went ahead and used the object programming book in Java. So all my sources are already down there as clarity. I don't know if there's a question I would ask here. Why is binary search faster than linear search? Just as an example, and that agent literally is a simple agent. It's a question retrieve answer. So it's going to take the time. You can see looking for best response. And as it looks for best response, it comes and answers you very, very directly. Tuko sawa? Cool. It's making sense how things work out. On the N10 workflow course, I know we have a retrieval that can be done on N10 as well, using a company database. Cool. And then you can see even the answer is very anchored based on how things are done on the book. Right? So for those of you who do this one, like the log 2, base 2, all those sort of comparisons, they're well covered because they're coming from books. It only starts with the sources. The final thing, this one I can't demo because it needs a human in the loop. Is this one another agent that we've built internally? Is our question was how much time are instructors spending on doing assignments, and can we be able to get an agent to review assignments? However, the review assignment has a human in the loop. When the AI reviews, the output goes to the instructor before it goes to the student. You guys understand why that might be there, right? So what this does is the goal of the agent is to review the assignment. The context the agent has is the assignment description, right? The assignment submission, and the rubric from the teacher. Does that make sense? So that's the context we're passing here. When we get the assignment, now this agent is purely about toolbox. So this person might have submitted an assignment as a PDF. They might have submitted an assignment as a Google Doc, right? Or it could be a coding repository on GitHub. We don't care what the assignment is. When we get the assignment, the first thing we're going to say, if this assignment is a coding project, call the GitHub. If this assignment is a Google Doc, we'll call the Google Doc tool to read and get that sort of data. You guys are starting to see how we start using those tool calls? Make sense? Now, let's imagine you have a coding project. It's going to use the GitHub tool to read the code. After it reads the code, it's going to call this code sandbox tool to run the code. Right? If this student also had a live URL or whatever they needed, it's going to use the browser tool to go look at the website, and then at the end of the day, based on the rubric, you give someone a review. Does that make sense? So you can, in fact, we don't care about this, you just feed the tools to the model and then it does it. That's where I'm going to wrap it up today. I don't know if anyone has a question. So status, how was the session on a scale of this to this? Achatuone, thank you very much. Thank you very much. All good. Now question, what agents are you guys thinking about and how have you changed your approach to doing those things? I just want one answer and then I pass it off to the final phase. Anyone? How many more get you already? That's not practical. You can also let me know. Someone online, can you save me from the misery I have over here? Anyone, just one person to contextualize it. Okay. Yes.
So I was wondering, sorry, I wasn't here for the first session, but I'm thinking, do some of these agents currently exist?
Which agents? All the agents I'm showing you as being exist.
No, for example, say I'm looking for an agent that can communicate to my database, my relational database that's specific to my organization or the company that I work for. So I don't know if I have the capacity of creating an agent currently about that. So I'm wondering, do I need to identify someone to create this agent for me, or do some of these exist and it only has to be customized
To your tool. I'll be honest, some of them exist and you can customize it for your tool. Sometimes for workflows that are custom for your company, you might need to either get someone to create it for you, or it's not so difficult to create. In fact, the final 5 minutes we have today is just showing you the different course flows we have and how it can allow you to do certain things. Like everything I've talked about theoretically can be done on any 10 if you do like the AI workflow automation thing, and all of a sudden you can create full workflows that help you to do something like that. Because it's accessing a database and answering it, right? For people who are developers, we have courses that are structured for developers to be able to build agents on that database flow. So it's all based on what do you need. And then the final fallback is always, what if I just don't want to build it, right? Who would I want to build that for me? And I hope today the context helps you. When someone says they're building it for you, you know the structure of the agent to expect, right? So everything is possible from what you say. They did say icebreaker, but I think we'll just move into the final piece. I don't know, just should hand it over to me. Right? I don't know if there's anything else. You owe me a comment. Okay, sawa, no pressure. Okay, guys, we now go ahead and wrap up our session today. It's always good to talk about theory, but it does not make sense if you cannot actualize it. So for us, we are going to contextualize what we've covered today into what is likely to be your particular AI job, right? I will do this very, very quick. If you don't mind, we can just call masses like we just wrap it up 100%. Okay. So at Zindua, what we've done here is, I know we are coming late to the market when we think about agentic systems, and that's what fair is. We just wanted to be clean on their approach, right? It's all about understanding the market movements and where a lot of the research is happening and seeing that. And you are able to encode what an AI roadmap looks for anyone into 4 critical levels. There's level 5, but level 5, Kenya as a nation, we might not have capacity. So we have level 1 is, what if you have no background in coding, but you wanted to build agents? You get right there. And I might be speaking to one of you over here. It's possible. We have tools like Agents where you can do workflow automation. Once showed us already do the example in the morning session. The second thing is, some of us want to be able to just use agents that exist in the UI. We've asked that particular question. Some of us may come in and say, probably we can't build a coding agent, but how well do I get the most out of our coding. How do I use that keyword code that everyone's talking about? No, right now we don't even just use it for coding, just a moment, but we will use it for things that are coding. You can get your cloud coding to be your number one market, right? Or you can take action on your computer and do all those sort of things. So we have like a level 2 down there. How can we start building with AI tools that are there? How can we build minimum number of products without training a single line of code, right? And then level 3 and 4 are now what we call AI steroids. What if you already use all these tools, you want to maximize your output, right? What if you're already a developer, you want to become an AI ML engineer so that you can scare people with acronyms like RAG and MCP, right? So we also have something for that as well. But regardless of where you're on the workflow, the core thing is we are stepping away from just base automations to intelligent automations. We're stepping away from humans being required for everything to agents working alongside humans in order to create things. And just to make this easy, I'll let the people who understand the context behind each and every one of these courses just say a few words about them, and then we can wrap up the day as well. I think we're not starting with just, we're actually starting with viewers, which is the AI workflow. Awesome. You have
Nice. So we are officially launching 3-tier masterclass series just to go above and beyond what we covered today. So we're calling it the no-code AI automation with 80/10. So it does not require you to have any technical background. Exactly what I did and automated my CV screening with literally 4 nodes on NA10. And NA10 is honestly plug and play, right? It's called what? Copy pasting that on is drag and drop, right? It's literally drag and drop. If you can break down a process into logical steps, you can automate that process. And NA10 doesn't require you to code in order to automate that process. The only skill there that you need to perfect is taking a process and breaking it down into chunks. The rest will be handled by the awesome platform called NA10, and it will do the orchestration for you, the connections for you, and all that, all those good stuff. So we will have 3 Saturdays. For the first Saturday, our masterclass series, we will learn the basics of NA10. What is NA10? How is it able to do what it does? And I promise to keep it as non-technical as I can. What are the nodes? How do we create connections across the popular apps? So connecting your Gmail to your Google Sheets to your WhatsApp. We're gonna have examples of that, and how these things can can communicate with each other. Connecting to databases, connecting to Twitter. If you wanted to get data from Twitter, to synthesize, maybe your Safaricom and you want to know how are people, or maybe you're the root of government, let's go there, right? How are people feeling my governorship, right? She's not happy. How are people feeling my governorship? You can scrape data from Twitter using its APIs, and you can call an LLM to do sentiment analysis for you and write a report. Those are the amazing things you can do with zero technical background, right? So that will be the Saturday number 1. A good introduction to NA10, how things communicate with each other, and you're going to have built a complete work, right? Next will be, you saw in my workflow, you saw how I gave my LLM instructions, right? Now that's taking it to the next level. After you created our workflow, and the workflow depends on an LLM, how can I make it better? How can I improve the output and even optimize the workflow in terms of making it costless? Remember, anytime you ping ChatGPT for an answer, you are spending something called tokens. I don't know why. You've heard about tokens, right? How do we optimize the workflow to be token efficient, right? How do we write proper prompts? So it gives us the output that we actually desire. Garbage in, garbage out with all elements. You give it vague instructions, it will give you a vague output. You give it very rigid, like he said, you give it very rigid instructions, it's going to give you a very rigid response. So we're going to, here it's all about how do we strike that balance in terms of prompts and how do we optimize the entire workflow so it's cost effective. Remember, these tools, not all tools are free. So of the tools that are not free, what are some of the things you need to do to make sure that your workflow is not eating into your focus, right? And then lastly will be building low-code agents. How can we build a RAG, right? How do we build a RAG on end-to-end, right? An agent that actually goes and books a flight for you. An agent that actually puts calendar invites for you. So we're going to give an agent the tools, we're going to give it a goal, and we're going to give it a series of steps that activates it, right? And we're going to see, what's it called? Fast, what's it, when you say fast, we're going to see like, right, how A10 makes this complicated, I don't want to say complicated, how it makes this multi-layered system very simple as just dragging and dropping and saying, okay, my vector database that you taught, this is where I want you to get your context. How do we set up a vector database with no code, right? How do we give our database memory? How do we give our database a brain? Our agent a brain, memory, etc. So that's for the next Saturday, starting from the 11th of July, and every Saturday until the end of July. That's what we'll be covering. And I hope I see all of you next week. Right. I'll hand it over to Jesse for.
Okay, thank you, Mercy. Yes, good. I know we've been here for a while, a lot of technical knowledge to talk, so I promise to not take your time at all. My name is Jesse Karanja, I'm also one of the co-founders. I do a lot of things, but sort of by taking on software, and so by virtue of that, I'm taking you through the build with AI. And I'm sure we've learned a lot about agents today, a lot of technical things. I think props to Mercy and Cyril for that. And the fact of the matter is, at the end of the day, we need a product or somewhere where all these agents live, basically, for lack of a better word. And so we build, for the Build the AI program, or series of masterclasses, we'll be looking how we can move from idea to a deployed product using AI, pretty much. So also, in summary, what we be. And so in 3 Saturdays, similar structure to what she has been able to explain. The problem with most of us, but I know we've all tried something. We've all tried Lovable V0, right? Just by a show of hands, who's tried Lovable V0? Just 2 people, yeah? Claude, a lot more people. Zindua. What you do, or at least the mistake we do often, is actually going straight into generating screens. We let AI be able to dictate how it will be able to look. And one thing you realize, yes, Lovable is going to take you from 0 to about 70-80%, but beyond there, chances of it breaking becomes very, there's a high probability of it breaking. And I'm sure for those of us who try, you'll be able to tell. Probably for a single site website, you can be able to do that. But the moment you're now building a product, or actually now a system that needs to be used, has a backend and so on and so forth, you realize you actually need a lot more. So that's what we'll be looking at. First of all, design is the rulebook. How can you define your design system? What are your fonts? What are your brand colors? How exactly do you want it to look like? Be able to even feed screenshots as inspiration, so that you're able to define that. And the moment the AI coding assistant starts generating your product, they actually guide them in terms of the visual element of how it looks. From there, how do we translate design to code? For those of us who started coding way before pre-ChatGPT, right? Or pre-AI. Remember, you had to jump onto Figma, do all those components and everything manually. Then now open an IDE, start writing code from scratch, then deploy, right? And it take you a lot of time. We didn't have ChatGPT or Claude to refer to. So at the time we had Stack Overflow, some Indians on YouTube would assist you, right? But at least now we have AI which you can leverage, and that's essentially what we want to teach. So that now, whatever used to take us maybe 3 to 5 months to build, probably a team of two, 3 people eating up a lot of resources in time and money, you can be able to even do it as yourself in a month or two. And the essential thing here, before you even go to the third bit, is that it's not about the tools or the models, really. It's not about Claude or Codex. You can choose whichever you want. I think at the end of the day, it's coming out with a workflow that actually works. Whatever you build at the end of the day is something that will be repeatable, such that whatever it is you want to build, even internally, when we talk of entrepreneurship, probably your employee, there's a certain issue you see. Probably there's no quick example, maybe like an asset management system, right? And you think you can actually develop this just for fun for your employer. This is something you can be able to, pretty much get onto and be able to deploy. The third one is, of course, shipping. When we talk of designing to code, this is when now you even have a skill.md file where you're able to now just define all the fundamentals in terms of everything that's important that you want to be able to guide your coding assistant, so that the moment now it starts generating code, it's within the defined design system and the defined rules that you actually want. And of course, the final one is shipping it, whether it's on Vercel, whether it's on Netlify, it doesn't really matter. But at the end of the day, you come out with a real application, deployed in live, and you can keep building over and over again. At the end of the day, it's just about the workflow and having a repeatable system that you can be able to build. So you have the ideas there. If you have an idea, you always want to now find a way to actually bridge that gap between the idea and seeing it live and being used. Whatever lies between here is the building the AI program. So awesome. Karibuni sana. We're happy to have you with us.
Okay, awesome. So far, ideas, guys, ni wangapi? All of us don't have ideas. Okay, automation people, you want to save time? Thank you. At least you have 2 people. Everyone else, I have something for you, right? So, now, when we step beyond those 2, we now get into what I call AI on steroids. Why should you go to the gym if you can inject yourself with steroids? I'm joking. You can also inject our AI with steroids and make it operate in a different way. Autonomous AI is exactly, this is a short course, it's not a masterclass series. It's going to span 6 weeks or 60 days to be precise. This is how can we get AI to work for us even when we are asleep. A lot of the time when you talk about our typical systems, even when you're building AI, you're talking to it, connecting to it, right? Right now we've gotten tools that allow you to just text your AI agent on Slack, on Discord, on Telegram, right? Tell it, you know what, I want you to go audit our social media today. Give me a report. Does that make sense? This course across those 6 weeks will take you from 1, how do you deploy these tools that allow you to make AI autonomous, right? 2, someone here asked about deploying their own model, right?
Oh, Franklin.
Yeah, Franklin. Franklin, you asked about deploying your own model. We cover being able to use open router models as well as your own models within your autonomous AI systems. And then we talk about agentic harnesses. When you hear Claude Code, how people use it to milk the most value out of it. How is it that we have companies that have written the entire company portfolio in skills that you can use today and get the same output they get at any given instance? How can you maximize tokens and get the most output out of that? All this you're doing such that your autonomous system never has to have data touch from you. And then finally, how can you do what I call multi-agent orchestration? In English, this means you can talk to someone who's a CEO, it hires other agents, every agent does their own thing, and then it comes back to the CEO reports and you just have a final check-in on this one. There's a lot of tools like OpenClaw. Anyone who's heard about OpenClaw? Cool. No one, anyone who's heard about Paperclip, that allow you to start having autonomous companies, autonomous systems that don't need humans or that can interact with humans 100%. So once again, if you're used to going to the gym, it might be time for steroids. If you're used to AI workflows that you just have to look at, this 60-day workflow will transform you from just prompting or just using tools to being able to create your personal systems with your names that you call for it. I'm personally a beneficiary of it. I text my agent, it talks to me, right? In our coding team, we have people who do reviewers who are deploying agents. They just wait for the code to be submitted, and the moment the submission comes, they can that code review automatically. So there's a lot of big advantages to be able to get this beyond what we typically do. Now, the final one, just to close the day, how many of us are software developers or data scientists? How many of us can code? Right? One person, two people, three people. The final thing we'll go ahead and say, I don't know what's the issue here. Just my apologies for the guys here, I should clear. The final level and core thing is if you're a developer and you want to build everything we've talked about here today with code, not just with no code, we're going to be having an applied AI engineering course launching in October, to be precise. Everything I've talked about agents is going to be covered in the workflow automation, no code wise. But everything we've talked about, we're going to now engineer it for proper advanced applied AI, right? From understanding LLMs in depth, from being able to build these agents, right, into your typical code. You can build something like Verge or Rukia Labs by yourself. How do you do prompting and such agents? When do we call the tools? How do we optimize memory, right? How do we evaluate and tune these models? And how do we also do RAG and fine tuning? This is a full holistic workflow that takes you from just a developer who can work with AI to a developer who can engineer in production systems around AI. With N10, you can do no-code workflows to a very great degree, right? But with code, you can advance those workflows and get it embedded into your company systems with even more might. This is now when you can start writing a chat tool like ChatGPT, right? You can build a legal AI assistant that people can use in a very different thing. N10, great for in-company use, great for personal use. When you talk about AI agentic engineering, great for large production use. And this is primarily for engineers, but open for anyone who can write a line of Python, and you'll be able to maximize all that. So that's our flow of the 4 courses. Once again, there's AI workflow automation, ideal for being able to build agents without touching a single code. We have building with AI, ideal for you to be able to build minimum viable products without necessarily having to write code. Autonomous AI, where we inject steroids into our AI workflows, right? And then finally, we have applied the engineering, which is actually cloud certified. So this is actually going to be a cloud certified specialization course for developers that allow you to move from just a software developer, data scientist, to an AI engineer. I'll take one final question and then we close the day then. Yes, finally, thank you.
My question was, the AI agent we have in the LMS, some students, can we use N8 to build the agent code?
Yes, you can use N8 to build a chatbot. There's only one restriction for N8. It has to interact with the existing tools because it doesn't have a front end. So a good example is when you engineer from scratch, you can create the interaction phase for that. When you're using N8, you can say I'm building a chatbot that people can text on Slack, on WhatsApp. You get it? Because now what you're doing is WhatsApp is the input, right? N8 runs your workflow, and then WhatsApp is the output. You see the difference? With AI engineering, you can design the front ends for it, the full architectures for it. With N8, you're connecting it to these workflows there. Okay? But you can, I don't know if you can on the LMS, you can't on our LMS, but I'm just trying to say you can build an agent and say when a student asks questions about code, you can get an answer. So that's very, very possible. Cool. Any final question? I can't see Grace around, so I don't know. Should I just wrap it up? Cool. Someone give me a question as you wait for Grace, right? The QR code. Oh, the final thing I'll go ahead and say, if you guys can see my screen, I don't think the guys online can see my screen. I don't know when it dropped. Okay, so at the moment we have the QR code for the AI workflow automation active. So if you want to register for it and just be in tune for that, I'm feeling really sad. I don't know how many of you have the call on your end. I don't know why it's not coming. I don't know, it feels like it's been too much. Okay, can I just promise this? If you just search AI workflow automation Zindua School, you'll be able to get the course. However, you will get the URL to all the courses that we have here, and you just choose whatever level is best for you. In fact, to be precise for the guys online, I will just put the URL there and we should be good to close it off. I'm done, Grace. I'll just hand it over to you. Sijui mbona itumie.
You're sharing your screen.
Yeah.
Okay.
I don't know why it can't send. So you just send the link in chat.
The what?
The link here.
Oh, inakata. What is it on email? So that's okay.
Share.
Okay, guys, that wraps up our masterclass and workshop for the day. I hope you enjoyed. I don't know if you shared your take home. I missed better part of it. I just need 2 volunteers to share what they have. They are taking 2 volunteers. If you don't volunteer yourself, I'll volunteer you. So raise your hand. You have something to share. I'll volunteer someone. Okay.
This workshop, I can say, there are those few details. I think most people will be there. You agree with me that you tend to use, you have some very powerful tools, but you don't end up getting the right results as what you want, despite they are creative, anything, you name it. So we thought we had how to contextualize whatever you're working on, and also using those great analytics tools that we can and give us like, let's say I'm working with something animation. Rather than going with Gemini Flash that gives me comments and things like that, I can just put that AI work with any plugin with feedback. It can be a good tool, you understand, rather than being general, whereas I need as specific as it's all. This can be
I guess which one? Sandy. Thank you, Sandy. I need one more for the girls. Someone to represent the girlies in the house. I'll volunteer the lady at the very back on the corner.
Hi everyone. My name is Faye. I came in for the second session. I think it was really informative. I think also I just take also the person was showing the presentation and how she goes through the hiring process. I think that gives so much perspective. Of course now I'm going to 3 years to learn information and try to understand how I can create or in my day-to-day life. So I recognize the masterclass has been done for 2 years. Yeah, I want to explain that.
Okay, I don't know if the online people are still listening, but you can feel free to drop on the chat what you are taking home today. We're so grateful that you chose to spend your Saturday with us. I hope you've gotten a take home, and I'm hoping to see you all in the AI series. By now, you should have gotten an email with all the links, the slides that were used today, the link to the AI series, and also a link to join the WhatsApp AI community. Feel free to join and share what you've learned. And I'm hoping to see you all in the AI series. That's it from us today. Feel free to network after we're done here. Talk to someone new as you leave here and try to you've known somebody new. All right. If you have further inquiries, we have a inquiry desk at the reception. Also, you can feel free to talk to any of the technical mentors who've taken us. All right, a round of applause for all our facilitators for today. Thank you, and now a round of applause for you.